Good morning, everyone. My name is Tamu Gibson, and I will be serving as your designated federal official for the U.S. Environmental Protection Agency's Federal Insecticide, Fungicide, and Rodenticide Act Scientific Advisory Panel, FIFRA SAP. For this meeting and in my role, I will be opening this public meeting, and I want to thank Dr. Bob Chapin for agreeing to serve as the chair of the panel for this meeting. I also want to thank members of the FIFRA SAP, the ad hoc reviewers, and the public for attending this important meeting. We appreciate the time and effort of the panel members in preparing for this meeting, taking into account their extremely busy schedule. In addition, I want to thank EPA's Office of Pesticide Programs, OPP, and to my colleagues at the Peer Review and Ethics Branch in EPA for their hard work in preparing for this important review of EPA's examination of microsomes and mesocome studies for evaluating the effects of atrazine on aquatic plant communities. Also want to thank my colleague Steve Knott, Chief of the Peer Review and Ethics Branch, Mission Support Division of the Office of Program Support. I want to also thank Dr. Ala Kamel, who is online this week and will serve as my backup role as designated federal official. Thanks are also due to Dr. Charlene Matten and William Woogie, who are our Assistant Deputy Ethics Officials. And I also would like to thank Ms. Joyce Coates and Ms. Barbara Ewell and our contractor, Kurt Ali, and William King from Indana, who provided the administrative support. By way of background, the FIFRA SAP is a federal advisory committee that provides independent scientific peer review and advice to the agency on pesticide and pesticide-related activities on human health and the environment. The FIFRA SAP only provides advice and recommendations to EPA. Thus, decision-making and implementation authority remains with the agency. The FIFRA SAP consists of 7 charter members. The expertise of these members are augmented through the Food Quality Protection Act Science Review Board. The Science Review Board member serves as ad hoc temporary participants in FIFRA SAP activities, providing additional scientific expertise to assist in the reviews conducted by the panel. For the present meeting, 9 ad hoc expert reviewers have been added, and 6 out of our 7 charter FIFRA SAP members are contributing to the peer review of this review. Please note that the agency does seek and encourage consensus from the panel. Consensus recommendations will be most useful to the agency. Therefore, the chair for this panel has been asked to lead the discussions to promote and facilitate the panel members reaching consensus to the greatest extent possible. However, please note there may be instances where the panel will be divided and unable to reach consensus on an issue. This is okay and will be captured in the final report and meeting minutes. In these circumstances where a consensus is not possible, the panel should be clear, providing the majority and minority opinions in this document. As the DFO for this meeting, I serve as the liaison between the FIFRA ACP and the agency. I'm also responsible for ensuring provisions of the Federal Advisory Panel Act, FACA, are met. The Federal Advisory Panel Act of 1972 established a system that governs the creation, operation, and termination of executive branch advisory panels. The FIFRA SAP meetings are subject to all FACA requirements. These include open meetings, timely public notice of meetings, and document availability, which is provided via the Office of Pesticide Programs public docket at regulations.gov. As the designated federal official for this meeting, a critical responsibility is to work with appropriate agency officials to ensure that all appropriate ethics regulations are satisfied. In that capacity, panel members receive training on provisions of the federal conflict of interest laws. In addition, each participant has filed a standard government confidential financial disclosure report. Our deputy ethics official for the Office of Program Support and their team is in consultation with the Office of General Counsel, have reviewed these reports to ensure that all ethic requirements are met. The FIFRA SAP will review challenging scientific issues over the next 3 days. We have a very full agenda and meeting times are approximate. I will repeat, we have a very full agenda and meeting times are approximate. Thus, we may not keep to exact times as noted due to panel discussions and public comments. We do strive to ensure adequate time for agency presentations, public comments, and panel deliberations. For presenters, panel members, and public commenters, please identify yourself and speak into your microphone since this meeting is being webcasted, transcribed, and recorded. For those joining by phone, I'd like to note that we have a live video cast of this meeting. To access it, please go to the link in the meeting website listed in the agenda. Copies of all EPA presentation materials, written public comments, and other documents related to this meeting are available in the public docket at regulations.gov. The docket number and website are noted on the agenda. Members of the panel and the ad hoc reviewers are encouraged to fully consider all written and oral public comments submitted for this meeting. We dedicated adequate time for the agency presentations, public comments, and peer reviews to discuss their questions. As we move through the proceedings and if time allows, we may be able to move to the next agenda item if an item takes less than anticipated time. For members of the press, EPA Media Relations staff are available to answer your questions about this meeting. Please address all your questions to press@epa.gov. At the conclusion of the meeting, the FIFRA SAP will prepare a report as a response to the questions posed by the agency, the background materials, the presentations, and public comments. The final report also serves as the meeting minutes. We anticipate that the final report and meeting minutes will be completed 90 days after the meeting is concluded. Again, I wish to thank the panel and ad hoc peer reviewers and the public for their avid participation. I am looking forward to both a challenging and interesting discussion over the next 3 days. At this time, I now turn the meeting over to our chair, Dr. Bob Chapin. Dr. Chapin?
Thank you, Tamu. Much appreciated. Good morning, everyone. And I'd like to acknowledge those members of the panel who are joining us from the West Coast and the Mountain Time zones. This is early in the morning for you, and we appreciate your diligence and participation. So now we'd like to go through and have each of the panel members introduce themselves and give a short sentence about their expertise. My name is Bob Chapin, and I'll call on you. My name is Bob Chapin, and my subject matter expertise is mammalian reproduction. So now the next, we'll start off with the FIFRA panel members, Dr. Barakal.
Hi, my name is Veronica Barakal, and I'm a professor in the Department of Statistics at University of California, Irvine. And my expertise in statistics, biostatistics, environmental exposure assessment.
And congratulations on your recent promotion.
Mm-hmm.
Dr. Harry.
Hi, this is. Yep. Good morning, everybody. This is Jean Harry. I'm at the National Institute of Environmental Health Sciences. I'm in the mechanistic toxicology branch. My expertise is focused mostly on neurotoxicology, but on inflammation and immune responses.
Great, thank you. Dr. Murphy?
Yes, I'm Dr. Cheryl Murphy. I'm a professor in the Department of Fisheries and Wildlife. and director of the Center for PFAS Research at Michigan State University. And my expertise is in ecotoxicology and adverse outcome pathways.
Thank you. Dr. Sabo Atwood.
Morning, Tara Sabo Atwood. I'm professor and chair of the Department of Environmental and Global Health at University of Florida. And my expertise is in ecotoxicology, mostly with fish models, and pulmonary toxicology as well.
Great, thank you. Dr. Tron.
Good morning. I'm Lisa Tron. I'm associate professor at Oregon State University in the Department of Environmental Molecular Toxicology, and my focus of research is on the mental toxicology and computational modeling.
Awesome, thank you. All right, now for our Science Review Board members, the FQPA folks, Dr. Chen.
Yes, I'm Chen. I work for the New York State Environmental Conservation. My responsibility there is to do risk assessment on pesticide products. My expertise is physiology, toxicology, and ecology.
Wonderful, thank you. Dr. Felsat.
My name is Alan Felsat. I'm a professor at Washington State University. Before that, I was at University of Illinois. My research expertise I just generally describe as environmental toxicology.
Works. Great, thank you. Dr. Farrell.
Hi, I'm Jay Farrell with the University of Florida Center for Aquatic and Invasive Plants. My research emphasis is weed science and invasive plant management.
Thank you very much. Dr. Getzinger.
Good morning. I'm Kurt Getzinger with the U.S. Army Engineer Research and Development Center in Vicksburg, Mississippi. And my expertise is evaluating and developing techniques for aquatic plant management, focusing on herbicides. And please don't put me in the penalty box.
You're safe here. Dr. Hager.
Good morning, all. My name is Aaron Hager. I'm professor of extension weed science here at the Department of Crop Sciences at the University of Illinois. Work collaboratively with my colleagues here at the University of Illinois on a myriad issues around weed science, in particular, trying to better understand the evolution of herbicide resistance in the Amaranthus complex.
Awesome. Dr. Madsen.
My name is John Madsen. I'm recently retired from the USDA Agriculture Research Service in Davis, California, and moved to the income tax-free state of Tennessee. I'm a botanist, an aquatic plant ecologist, and aquatic plant management specialist.
Great, thank you. Dr. Marlborough.
Good morning, I'm Sidney Marlborough. I'm the Senior EHS Manager for Continental Carbon Company. I have expertise in marine and aquatic ecotoxicology, as well as endocrine disruptors and molecular biology. Thank you.
Thank you. Dr. Schmidt. Dr. Schmidt. Well, I'm not seeing him, so, okay, we'll, Dr. Sibley, finish up with Dr. Sibley.
Dr. Schmidt is there, but he's muted. So anyways, good morning. My name is Paul Sibley. I'm professor and director for the School of Environmental Sciences at University of Guelph in Guelph, Ontario, Canada. And my area of expertise is as an ecotoxicologist with specialization in aquatic ecology, aquatic toxicology, and in particular on invertebrates.
Okay. Dr. Schmidt, can we, are you unmuted now?
Yeah, we still can't.
Can you hear me?
Yes,
oh,
we can hear you. Okay.
All right. Sorry about that. My computer switches microphones sometimes. I'm Dr. Travis Schmidt. I'm with the U.S. Geological Survey in Helena, Montana. My expertise is ecotoxicology in general, and I run a mesocosm lab in the Department of Interior called the Montana Experimental Stream Observatory.
All right, so it sounds like we've got a whole bunch of the right expertises around the table. So I'll turn it back over to you, Tamu.
Okay, and now we have opening remarks with our Deputy Assistant Administrator for Pest Programs, Jake Lee.
Great. Thank you, Tamu, and good morning, everyone, and welcome to this week's FIFRA SAP on the topic of re-examining some studies that EPA used to evaluate atrazine's impact on aquatic plant communities. I want to thank you all so much for being here today and for dedicating your time and expertise to the FIFRA SAP and to EPA. This is actually my first time speaking at one of your meetings, and it's also the first FIFRA SAP meeting since September 2020. So I wanted to start by recognizing our returning members, Dr. Chapin, as we've been hearing from, Dr. Barakaw, Dr. Harry, Dr. Murphy, Dr. Waisel, although I did not see him mentioned going around the sort of screen here. So
yeah,
he's not.
He's not at this meeting.
Okay, not at this one. Okay, thank you for clarifying that. I also want to acknowledge the new members of the SAP, Dr. Sable Atwood and Dr. Trung. Thank you so much for your expertise, time, and energy. Your feedback and involvement are really important to EPA. This panel advises EPA in answering complex science questions so that we can make the best decisions possible. You help us to know when we're headed in the right direction and when we need to do more work. At the core, you help to ensure that EPA is effectively accomplishing our mission to protect human health and environment. Atrazine is one of the most widely used agricultural pesticides in the country, with the highest use on field corn, sweet corn, sorghum, and sugarcane. We also know that it can pose risks to the environment, one of which is the aquatic plant communities. And aquatic plants are absolutely vital to our aquatic ecosystem. So we need to better understand those risks so that we can effectively mitigate for them. Scientific studies, like the ones being presented in this meeting, help to inform EPA's understanding of those risks. Our discussions about these studies will help improve our understanding of what the concentration level of concern, or a CLOC, for atrazine should be. This is the concentration of atrazine that, when exceeded, presents a greater than 50% chance of harming an aquatic environment. The focus of this SAP is EPA's reevaluation of 11 COSM studies and the associated publications. It is not about how the CLOC was derived. None of the charge questions pertains directly to the CLOC, so we won't be discussing the CLOC directly over the next 3 days. But EPA does want to briefly provide background on how we got to where we are today on atrazine and why this SAP is so important for our path forward. Back in 2016, EPA released the Atrazine Ecological Risk Assessment, which said that the level of concern for atrazine was 3.4 micrograms per liter when measured as a 60-day average. But when it came time to propose an interim decision for atrazine, the political leadership at the time directed career managers to exclude some studies in order to reduce the CLOC. The managers refused to carry out the direction, and instead, in October 2019, EPA released a memo that announced a policy decision that an atrazine concentration of 15 micrograms per liter as a 60-day average would trigger monitoring or mitigation. That 15 microgram per liter regulatory concentration is different from the CLOC, which EPA believes has not changed since 2016. I also want to make clear that I'm not aware of any efforts to influence other parts of the atrazine proposed interim decision. Then, in October 2020, EPA received a petition for review in a Ninth Circuit Court of Appeals of EPA's interim decision for atrazine. That petition alleged that the decision EPA made was not supported by substantial evidence when it used the 15 microgram per liter regulatory trigger. EPA then requested a remand of the ecological risk assessment, which gave us the opportunity and the responsibility to revisit that policy-driven 15 micrograms per liter trigger that the last administration had chose. In response, this past June, we released for public comment the proposed revisions to the September 2020 atrazine interim decision, which proposed additional measures to decrease runoff and protect aquatic plant communities. And in line with EPA's commitment to science and science integrity, we are now seeking peer review from you on some studies that inform our science assessment about the risk to the aquatic plant community that underlies our proposed policy-based risk management strategy. We'll also take this feedback into consideration when making our decision. Since 2000, the agency has consulted with the SAP on 12 occasions on various topics related to atrazine data and key aspects of EPA's risk assessment. This includes past SAPs related to aquatic plant communities and the topic we will be discussing today. This meeting will focus on studies that are most likely familiar to all of you. The 2012 SAP indicated that these studies should be reevaluated, and some of the studies were flagged by earlier SAPs. The studies are complex, and they help inform our understanding of what concentrations of atrazine affect aquatic plant communities. Our latest reevaluation of these studies determined that 2 of the studies should be excluded, and the endpoints for others should be changed. We made this determination based on a more extensive evaluation of the methods, results, and the public comments over the past 2 decades. We're really looking forward to your feedback on our approach as we determine whether any adjustments to it are needed. Thank you again for participating, for your time and commitment to the SAP. Peer review is part of the foundation of EPA's work. We need to let the best science guide us in order to make the best decisions. Your role and the role of the SAP is very important to that process. Per the SAP organizers, I also wanted to request timely completion of the meeting minutes and the report. Thank you in advance. I hope that the next 3 days are full of productive conversations, and I really appreciate the opportunity to speak with you today. Back over to you, Tamu.
Thanks, Jake. Have a good one.
You too. Thanks.
Okay, Dr. Chapin, now we're going to have the background and overview by Dana.
Sounds good.
Making sure everyone can hear me okay?
Yeah, I'm back.
Great.
Yeah, thank you. Sorry.
Good morning, everyone. Dr. Chapin and other members of the panel, my name is Dana Spatz, and I manage a multidisciplinary group of scientists that conduct ecological risk assessments and drinking water exposure assessments in the Office of Pesticide Programs, Environmental Fate and Effects Division. I want to thank everyone for your time and effort in reviewing our white paper on atrazine, and I look forward to a good discussion on the topics at hand. My goal in the next few minutes is to set the stage for the technical presentations you will hear from Dr. Kayla Coldsnow, Dr. Frank Ferrugia, and Dr. Michael Lowy. This week, we will be presenting EPA's reevaluation of 11 atrazine microcosm and mesocosm studies identified by the 2012 FIFRA Scientific Advisory Panel as warranting further review. These studies are part of EPA's ecological risk assessment of atrazine and are specifically used in assessing the effects of aquatic plant communities. What we hope to gain from the next 3 days is the panel's perspectives on our reevaluation of these 11 COSM studies, and whether you agree with EPA's proposed changes to the database of COSM studies used for analysis, specifically excluding some studies and endpoints while adding or adjusting other endpoints. Which brings me to the purpose of this meeting. We are looking for expert feedback on EPA's 2023 reevaluation of the 11 COSM studies that the 2012 SAP and public commenters identified as requiring additional evaluation. EPA's reevaluation includes the reconsideration of each of the 11 studies for its inclusion in the calculation of the concentration equivalent level of concern for atrazine, also known as the CELOC. And if appropriate, the results associated with the specific endpoint or endpoints from each study. The longstanding risk management goal for atrazine since 2003 has been to protect aquatic plant communities. Aquatic plant communities include phytoplankton, which are the free-floating plants, attached periphyton, and aquatic plants also otherwise known as macrophytes. Aquatic plant communities can contain complex interactions among members of the community. Aquatic plant communities are vital to both aquatic and terrestrial food webs, including fish, birds, and mammals. And in turn, they're important to ecosystem integrity. Microcosms and mesocosms, or collectively referred to as cosms, are great resources to study these communities. Some of the things cosms allow researchers to assess include many species across trophic levels, community structure and function, direct and indirect effects, and chemical fate. They offer more natural conditions than laboratory-based experiments due to things like temperature fluctuations, precipitation, and stratification. But they are time and resource intensive, which limits the quantity available in the open literature. All of this, plus the complexity of aquatic plant communities, means that the results can be variable and challenging to interpret. Unlike many other pesticides, there is a large number of atrazine COSM studies. EPA put each of those studies through a COSM screening and scoring process before being used in the risk assessment. The process included searching for COSM studies in the open literature in addition to those that were submitted to EPA. A study was then pre-screened for inclusion, which involved ensuring that the experiment only used atrazine, that concentrations were reported, that effects to aquatic plant communities were assessed, and that the study was written in English. After the initial screen, studies were further evaluated for inclusion, which involved considering things like presence of controls and the number of replicates. If a study passed the screening criteria, the duration, concentration, and results were extracted into a single endpoint. Those endpoints were then scored as an effect or no effect on the aquatic plant community using a scoring approach. After the endpoints were scored, they were used collectively to calculate the level of concern. The use of COSM studies in the ecological risk assessment of atrazine to determine an LOC has a long history, including multiple SAPs. The 2009 SAP recommended considering an alternative to the categorical Brock scores and reevaluating all the studies based on study quality and concentration-specific effects data. We recommended 38 more studies and commented on a few of the COSM studies relevant to today's meeting. In the 2011 COSM memo, EPA released a refined screening and scoring approach after consideration of the 2009 SAP comments, as well as the assessment of the 38 studies recommended by the 2009 SAP. Finally, the 2012 SAP suggested restricting endpoints to realistic durations and concentrations, which was adopted and discussed in the 2013 addendum to the problem formulation, and again in the 2016 refined ecological risk assessment. That SAP also identified 11 COSM studies that warranted further review, which brings us to the scope of today's meeting. The purpose of this meeting is to present EPA's 2023 reevaluation of the 11 COSM studies that the 2012 SAP and public commenters identified as requiring additional evaluation. The reevaluation includes the reconsideration of each study for its inclusion in the calculation of the CELOC, and if appropriate, the results associated with a specific endpoint or endpoints from each study. As mentioned earlier, there is a long history of atrazine SAP meetings that goes back 20 years. EPA has sought advice from the SAP on topics supporting the proposed revisions to the atrazine interim decision 8 times from 2003 to 2019, including on issues related to ecological risk, surface water monitoring, characteristics of vulnerable watersheds, the watershed regressions for pesticide or WARP model, aquatic plant community structural and productivity changes, determining the CELOC, evaluating and scoring microcosm, mesocosm studies, and gonadal development in amphibians. The single determinative issue coming out of the past SAPs where EPA differed from the panel's recommendations was the evaluation of the 11 COSM studies that are the subject of this SAP. Given the current proposed regulatory decisions for mitigating atrazine exposure using the CELOC, EPA decided to take this opportunity to conduct a reevaluation of the 11 COSM studies. The objective of EPA's SAP white paper is to present EPA's new 2023 reevaluation of these 11 COSM studies to address the issues raised by prior SAPs and public comments on the scientific validity and/or EPA's interpretation of the study results. Given the long history of interesting and complex scientific issues associated with atrazine, there will be a temptation this week to delve into some or all of those other subjects. Those topics include, but are not limited to, the screening and scoring approach developed after the 2009 SAP, studies beyond those reevaluated in the 2023 white paper. And I'll note here that in the 2012 SAP said that other studies, quote, do not need to be rescored because there is agreement on the scores, end quote. The CELOC methods used in the calculation, the 2019 regulatory update and 15 micrograms per liter as a trigger for decisions on mitigation, monitoring data, watershed modeling, mitigation measures, and others that are not listed here. I ask now and will remind the panel throughout the week if needed that we remain focused on EPA's charge questions around the 11 COSM studies discussed in EPA's white paper. Based on our 2023 reevaluation presented in the white paper, one group will remain unchanged because the previous comments did not change our overall interpretation of the study. 2 groups will be removed, including Lampert, which is often mentioned as a study needing to be removed from the database. And 4 groups will remain, but changes will be made to the associated endpoints, including changes in the effect, no effect conclusions, removal of endpoints, and addition of endpoints. Which brings us to today's meeting. These charge questions will be read into the record later in the meeting, but as you can see, the questions we have for the panel focus on our reevaluation of the 11 COSM studies, the 2012 SAP, and public comments identified as warranting further review. After this week's meeting, the SAP's final report will be due at the end of November. EPA will work to revise the CELOC as appropriate after consideration of comments from the panel during this meeting and the panel's final report. We have a total of 7 charge questions and a very full agenda. So I will stop here and introduce to you Dr. Michael Lowett, who will walk us through our reevaluation of the Lampert study group.
Good morning. I'm Michael Lowett, and a biologist in the Environmental Fate and Effects Division, or EFED, of the Office of Pesticide Programs, also known as OPP. My presentation is a high-level overview of EPA's review of the Lampert study group, which represents one of the studies under consideration that describes effects of atrazine exposure to aquatic plants. A more in-depth discussion is provided in the white paper. The Lampert publication is one of the 11 identified by the 2012 atrazine SAP as warranting further review and consideration. The scope of the charge questions associated with this and other study groups is whether EPA will include the study in the database of atrazine effects to aquatic plants. And if so, then what is the interpretation of the results? I will start with a brief overview of the Lampert study group, including some basic considerations of experimental design to set the stage. I will then briefly discuss how this study was used by EPA at the time of the 2016 registration review risk assessment. Then major concerns and criticisms from past SAP panels and stakeholders will be mentioned. I will then discuss key points from EPA's reevaluation in response to those collective concerns and criticisms from the past, and finally present EPA's current position on the study. There will be 7 additional study group presentations to follow. Each will follow the same basic format. However, the level of detail will vary. In some cases, there are multiple and independent issues that collectively impact the review, whereas in other cases, 1 or 2 issues may be the predominant considerations. Now, I will move to the overview section. Lampert et al. 1989 is one of the 11 publications identified by the 2012 atrazine SAP as warranting further review. Concerns were raised about this COSM study at earlier SAPs as well. The Lampert study group that I will be discussing includes consideration of the German dissertation written in 1988 by Fleckner, because specific information reported in the dissertation was used as the basis for some of the previous criticisms of the COSM experiment described in the Lampert publication. The dissertation violates one of EPA's basic pre-screening criteria because it is written in a foreign language. In other words, non-English study reports were automatically excluded from consideration. Importantly, though, the Lampert publication is written in English, so it does not violate the language criterion. However, in this case, consideration of the dissertation is key to addressing previous concerns about the experiment described in Lampert. Therefore, we translated limited portions of the dissertation identified as important to addressing the comments on the experiment described in Lampert and did not expand our review to include additional information or studies described in Fleckner, but not in Lampert. Next, I will provide a high-level overview of experimental design. The Lampert COSM experiment was conducted in a lake with plastic enclosures suspended from a floating frame. There was a single frame that had capacity to suspend 4 enclosures. Therefore, 1 concentration of atrazine was tested at a time with 2 treatment replicates and 2 controls. Water from the same lake was used to fill the enclosures with a filtering step to remove larger zooplankton. It's of note that although the study authors referred to the experimental mesocosms as enclosures, they were not completely enclosed. They were open at the top. There are uncertainties about the exposure regime, which underlie the basic concerns voiced about this study, especially the use of a solvent and associated control composition. Lampert explicitly states that a solvent was not used. However, Fleckner indicates that ethanol was used to dissolve atrazine. Furthermore, the composition of the control is not clear, but presumably it was a blank or negative control given the silence on control composition in both publications. In addition, Lampert is silent on the type of atrazine used, although the dissertation does indicate that it was 99% pure, suggesting that the material was technical grade active ingredient opposed to a formulated product. This slide illustrates that the experiment was repeated 6 times between 1981 and 1984, each time with one of the 4 different nominal test concentrations ranging from 0.1 to 100 micrograms per liter, which are represented by the bold circled numbers. The bold 0 represents the control. The number 2 in parentheses represents the replicates for that test concentration. As a reminder, the floating frame held 4 COSM enclosures, 2 controls, and 2 with atrazine exposure. Lampert only directly provided results for the experiments shown in the red boxes. In other words, the 1 microgram per liter experiment and 2 of the 3 repeated experiments with 0.1 micrograms per liter, referred to as warm and cold by Lampert as a description of the season when they were conducted. Therefore, EPA only considered those results for inclusion in the database of effects to aquatic plants. The other 3 experiments were mentioned in Lampert, 1 each of the 0.1, 10, and 100 microgram per liter treatment groups. But the complete results for those were only presented in Fleckner. Given the importance of the Fleckner dissertation to this reevaluation, those treatment groups were considered in the interpretation of the overall study quality for this reevaluation. Several biotic and abiotic variables were measured and reported in Lampert as associated with the aquatic community. I'll come back to some of these later, but won't be going into details. Statistical hypothesis testing was not provided. However, it was not a pre-screening or acceptance review criterion for study exclusion, and reviewer judgment was permitted for determining potential effects of atrazine exposure from provided data. Next, I'll present EPA's use of the Lampert publication as of 2016. The most recent EPA review of Lampert considered it of sufficient quality relative to the criteria for acceptance and review and the evaluation criteria to be included in the database of effects to aquatic plants. 2 endpoints, in other words, test concentrations, were extracted from Lampert and both were considered effects of atrazine exposure. As mentioned earlier, only the 1 and 0.1 microgram per liter concentrations were considered because only a text summary was presented in Lampert for the 10 and 100 microgram per liter test concentrations, which stated that results were like the 0.1 and 1 microgram per liter groups. Lampert also reported that there was a 3rd repeat of the 0.1 microgram per liter group and only stated that there were no effects without presenting any data. In other words, not only were there no statistical results provided for some of the experiments, but there was also not a clearly described and presented numerical and/or graphical presentation of those results. Therefore, they were not considered for the database. Next, I will present major concerns and criticisms of Lampert. The long-standing and overarching criticism about this study is the use of ethanol. Lack of proper controls, associated difficulties with interpretation of the results, and the potential impact of these factors on study validity. A public comment in 2022 summed it up as, the observed responses have been explained by multiple reviewers as due to the solvent, ethanol, which was apparently not used in controls, rather than to atrazine. At issue here is that Lampert expressly states that a solvent was not used. Yet the dissertation by Fleckner underlying this publication says that ethanol was used. The amount of solvent added to the COSMs is unknown, and there are questions about the impact of ethanol on the measured variables in the test system, especially the meaning behind the observed changes in dissolved oxygen. The implication has been that the use of ethanol could have caused or contributed to the system going from autotrophic to heterotrophic due to oxygen consumption by microbes, degrading the ethanol, and thereby confounding interpretation of the results relative to atrazine exposure. As mentioned previously, this has been a concern expressed by multiple SAPs. Now, let's focus on EPA's 2023 reevaluation. After consideration of previous comments, we identified a single determinative concern for this study, namely, that there was a potential impact of the use of ethanol on the interpretation of the study results as being primarily due to atrazine exposure. As mentioned before, Lampert was written in English, but with linguistic assistance provided to the study authors and indicates that a solvent was not added. In contrast, the original source, which is the dissertation written in the native German language, indicates that ethanol was used as a solvent, but only reports the amount used in the stock solution. Both publications are silent on the composition of the controls, so presumably they were blank or negative controls. Although the amount of ethanol added to the cosms is unknown, EPA estimates based on the stock solution suggest that it is plausible the ethanol degradation by microbes could account for a substantial amount of the observed reduction in dissolved oxygen, thereby impacting interpretation of this change as being related primarily to atrazine exposure. Furthermore, it is also important that there is uncertainty about the composition of the control, as any impact of the solvent cannot be deduced or accounted for without either negative and solvent controls or solvent controls alone. Here, I show original plots from the Lampert publication showing on the left panel dissolved oxygen on the y-axis and drops in the treatment group compared to the control over time on the x-axis at the 1 and 0.1 microgram per liter test concentrations. Although it is difficult to see the details on these original slides, graphs, they are included for visual context of the points being made in this overview. As mentioned, the drop in dissolved oxygen could be associated with oxygen demand for ethanol degradation. For example, EPA estimated a drop in oxygen of potentially up to 50% if the entire stock solution was added to a cosm enclosure. The panel on the right shows that zooplankton density in the treatment groups dropped compared to the controls over the same time period as changes in dissolved oxygen. Zooplankton abundance is on the y-axis and time is on the x-axis. Zooplankton abundance could have been impacted by the reduced oxygen levels and/or contributed to further oxygen depletion by decomposition of zooplankton by microbes. As shown in the panel on the left, recall the drop in dissolved oxygen. This is the same as on the other slide. Now it is compared with chlorophyll A over the same time frame in the panel on the right, with chlorophyll A on the y-axis. Changes in chlorophyll A represent a surrogate of biomass of the aquatic plant community. A drop in chlorophyll A from exposure to atrazine could lead to a reduction in dissolved oxygen levels. For example, this hypothesis is consistent with the 1 microgram per liter treatment group, which shows a drop in dissolved oxygen and chlorophyll A compared to the control. A consistent dose-responsive relationship would be expected if phytoplankton were the primary driver of changes in dissolved oxygen. However, in this set of experiments, there was not a consistent response as evidenced by the drop in dissolved oxygen of the warm temperature 0.1 microgram per liter treatment group. This is panel B with the W, compared to the control, but a lack of difference between the treatment group and control in terms of chlorophyll A. The lack of a consistent relationship supports the likelihood that the use of ethanol and changes to the zooplankton density may have impacted the dissolved oxygen levels in the cosms and confound interpretation of any of the results as being atrazine related at any given treatment level. The higher concentrations tested, that is the 10 and 100 microgram per liter, were presented in Fleckner. As evident in the left panel, the data for the higher test concentrations show the same drop in dissolved oxygen over time in the treatment groups compared to the control, as did the lower concentrations shown previously. The y-axis is dissolved oxygen concentration on the top figures, and the same data are presented as dissolved oxygen saturation on the bottom figures. Time is on the x-axis. In comparison to chlorophyll A in the panel on the right, there is no discernible difference of chlorophyll A among the treatment, the control, and lake water, which all drop in chlorophyll A concentration despite the stable oxygen levels of the control and lake water. The top and bottom panels show different size fractionations of the phytoplankton community. It's a little difficult to see here, but solid parallel lines are the treatment, the single solid line is lake water, and dashed lines are the control. The lack of relationship between dissolved oxygen and chlorophyll A is particularly evident in the 100 microgram per liter treatment group when accounting for variability of the lake, control, and treatment group replicates. Again, this raises doubt about the ability of these experiments to distinguish effects of atrazine from other factors. Finally, and notably, Fleckner reports a similar set of experiments with exposure to 2,4-D, which is a different mode of action than atrazine. In these experiments, dissolved oxygen showed the same drops as observed in the atrazine experiments. Like the atrazine experiments, ethanol was reportedly used. The amount of ethanol added to the columns is unclear, and there is no indication that the controls included ethanol. Just like the atrazine experiments, there is no clear drop in chlorophyll A of the treatment group relative to the control when accounting for variability of the lake, control, and treatment. And chlorophyll A dropped in the control even though dissolved oxygen stayed relatively constant. There was also a 500 microgram per liter treatment group, which is not shown here, that also showed a drop in dissolved oxygen, but with recovery. There are several sources of uncertainty with this study and potentially confounding factors that, when considered in combination, impact interpretation of the results. Fleckner indicates that ethanol was used, whereas the open literature publication by Lampert states that a solvent was not. There is also uncertainty about the amount of solvent that may have been used, and it is unclear if the experiment accounted for the potential effects of ethanol because there is a lack of clarity on the composition of the control column enclosures. Because these studies do not provide detail regarding the use of a solvent, there is not an effective means of determining whether there was a clear treatment-related response within or across test concentrations. Lastly, treatment levels were not tested concurrently, and as a result, each used zoo and phytoplankton communities obtained from the lake at different times. After consideration of additional information from Fleckner, the EPA considers the interpretation of the results from this study to be confounded by several factors that could cause changes in dissolved oxygen other than due directly to exposure to atrazine. More specifically, dissolved oxygen levels may have been impacted by degradation of ethanol and zooplankton. In other words, oxygen consumption through bacterial consumption of ethanol or decomposition of dead organic matter. Although the causal factors in this study are unclear, there are consistent changes among the atrazine treatment levels, including drops in dissolved oxygen and zooplankton abundance, both which could be associated with drops in dissolved oxygen levels. The similar studies with 2,4-D further suggest that ethanol is a potential confounding factor given declines in dissolved oxygen without a clear association with changes to phytoplankton abundance. Given the compounding uncertainties associated with the conduct of this study, for instance, the lack of a solvent control, and confounding factors associated with the study, for example, the potential impact of ethanol, the potential impacts on the phytoplankton community from exposure to atrazine cannot be reliably distinguished in this study. Now I will present EPA's 2023 conclusions for Lampert. EPA has decided to exclude the Lampert study group from the database of effects to aquatic plants, given the high level of uncertainty about attributing the observed changes in dissolved oxygen and the aquatic plants as being attributable primarily to atrazine exposure. This means removing endpoint number 58 and endpoint number 58B from the database. The key to EPA's evolved view of and conclusions for this study is the additional information obtained from the Fleckner dissertation. More specifically, the clear linkage across multiple treatment group levels and two different chemicals with different modes of action that consistently show declines in dissolved oxygen levels without concomitant changes in chlorophyll A. Although there may have been effects of atrazine on the aquatic plant communities in this study, there is too much uncertainty to reliably link atrazine exposure to observed effects at any given test concentration. Given the confounding factors, EPA has concluded that the Lampert study should be excluded from the database of effects to aquatic plants. Our charge to the panel is to comment on EPA's decision to exclude the Lampert study from the database of effects of atrazine on aquatic plants. Thank you for your attention. Are there any clarifying questions on this study group?
And this is directed to the panel as a whole. Any questions? Clarifying questions? Doesn't appear there aren't any questions at this time. Thank you, Michael. Dr. Lloyd. Thank you.
Okay. Kansas?
And at this point, is it Dr. Kayla Coatsnow? Presentation on the 1979 University of Kansas Study Group.
Good morning. My name is Kayla Coatsnow, and I'm a biologist in EFED. I'll be presenting on the 2 University of Kansas experiments, as well as the Kaczynski group later today. This first presentation is a high-level overview of EPA's review of the University of Kansas 1979 Experiment Study Group, which represents several open literature publications under consideration that describe the effects of atrazine exposure to aquatic plant communities. A more in-depth discussion is provided in the white paper. This presentation will follow the same outline of the previous presentation, including an overview of the study, major concerns and criticisms, and EPA's 2023 reevaluation. First, I'm going to provide a brief overview of the 1979 University of Kansas experiment and what publications went into the reevaluation. As I said, there were 2 experiments completed at the University of Kansas, with one occurring in 1979 that I'll go over in this presentation, and one occurring from 1981 to 1983, which I'll go over in the next presentation. The 2012 SAP had concerns with 5 publications associated with these 2 experiments, including 2 publications that present the 1979 experiment, the Noyles et al. 1982 and Kettle et al. 1987, 2 publications that present the 1981 to 1983 experiment, Carney 1983 and Dewey 1986, and 1 publication that presents them both, the Noyles et al. 1989. So the SAP had concerns with a total of 3 publications that present the 1979 experiment. In addition to these publications, 3 additional publications discuss the 1979 experiment, the Noyles and Kettle 1980, Kettle 1982, and Larson et al. 1986. These all discuss methods and results associated with the 1979 experiment and were included in the 2023 reevaluation. Similar to the white paper, in this presentation, the publications will be discussed collectively with separation only when relevant. So now I'm going to go over how the 1979 University of Kansas experiment was completed. The 1979 experiment was completed in large experimental ponds that contain 470,000 liters of water. The water was 2.1 meters deep. Plankton, which came in with the water, bluegill sunfish, channel catfish, and gizzard shad. These 3 fish species will be relevant near the end of this presentation. According to 6 publications that discuss the 1979 experiment, there were no grass carp, despite commonly being associated with the 1979 experiment. Potidnija, which are macrophytes, were also included, and then other plants and animals likely from natural colonization. The ponds received a single dose in late July 1979 of commercial grade atrazine, which was 40.8% active ingredient. And there were no other manipulations until the end of the experiment in December 1979. As far as the experimental treatments, there were 3 atrazine treatments, which were 0 or the control, 20 and 500 micrograms per liter of atrazine. There were 2 replicates of each treatment, and each atrazine treatment received 1 dose of commercial grade atrazine. The experiment lasted for a total of 136 days. And throughout the experiment, many abiotic and biotic parameters were sampled. For this presentation, only measured endpoints representing the aquatic plant community will be discussed. For the sampling of plant community, phytoplankton, filamentous algae, and macrophytes were assessed. Phytoplankton was assessed 4 different ways, including algal biomass measured via chlorophyll A, algal biomass via particle size analysis, carbon uptake, and lastly, species enumeration. For filamentous algae and macrophytes, the publications say that they were rare. They were assessed visually weekly, and there were also mentions, but no presentations, of qualitative recalls and aerial analyses. The Potidnija were checked for mortality, but the exposure duration was unknown. In addition to the biotic measurements mentioned here, atrazine concentrations were also measured and were 94 to 104% nominal on day 2. And then by day 92, they were 64 to 78% nominal. And finally, worth mentioning is that the publications do not mention any statistical analyses in the methods section, and there was minimal mentions in the results section. EPA's screening and scoring criteria did not include a requirement for statistical analyses, and in their absence, EPA's best professional judgment was used to make the effect, no effect conclusions. So now that I've given an overview of what publications are included in this group and went over the experiment, I'm going to go over how the EPA used the study most recently in the 2016 refined ecological risk assessment. To discuss the Gaussian database in 2016, I will show the figure I showed earlier when discussing the experimental treatments. For the 1979 experiment, there were 2 endpoints. Endpoint number 52 represented the 20 microgram per liter treatment, had a plant group of phytoplankton, and was classified as an effect. While endpoint number 3 represented the 500 microgram per liter treatment, had a plant group of phytoplankton and macrophytes, and was also classified as an effect. As you can see, these endpoints have different plant groups, which will be addressed at the end of this presentation. The way EPA used the 1979 University of Kansas experiment brought about concerns and criticisms, which I'm going to discuss next. For the 2009 SAP, EPA indicated in the white paper that endpoint number 52, 20 micrograms per liter, will be changed from a Brock score of 2 to a score of 3. The Brock scores went from 1 no effect to 5 significant effect without recovery after 56 days. This change in the Brock score is significant given the eventual change to a binary effect no effect scoring system where 1 and 2 scores were classified as no effect and 3 through 5s were classified as an effect. In the minutes, the 2009 SAP commented on the 1979 University of Kansas experiment, but there was some confusion as the SAP mentioned a series of studies exposed to atrazine for 136 days at 3 concentrations, 1, 20, and 50 micrograms per liter, which were not the concentrations in the ponds. Therefore, the 2009 SAP comment is not entirely clear to the EPA. For the 2012 SAP, in the white paper, EPA reiterated that endpoint number 52 was changed and that this change would result in an effect call with a new binary scoring approach. During the public comment period, comments suggested that endpoint number 52 be rescored to no effect. One comment concluded that COSM studies of the University of Kansas at Lawrence were the most ambitious ever conducted with atrazine in terms of size and complexity of the experimental ecosystems. In the minutes, the 2012 SAP commented on 2 publications associated with the 1979 experiment, Denoyles et al. 1982 and Kettle et al. 1987. They also commented on Denoyles et al. In 1989, but the comment was related to the 1981 to 1983 experiment. The comments included that there were no effects at 20 micrograms per liter and concerns about the fish, including about the abundance, survival, reproduction, and the presence of carp, which were not present in the 1979 experiment or discussed in either of the publications and will not be discussed further in this presentation. The panel also noted that these publications represent publications discussed by the 2009 SAP as having flawed methodology, which affect interpretation of the results. They also said these publications were considered ecological classics based on hypotheses tested, study complexity, and ecological relevance. However, they were not conducted under any semblance of good laboratory practices, or GLP. It's important to note that it's rare for open literature experiments to be conducted under GLP, and it's important to note that the experiments were not required to be conducted under GLP, but rather were required to meet EPA's minimum screening criteria developed after the 2009 SAP. In the 2016 refined ecological risk assessment, EPA reevaluated the 1979 University of Kansas group and concluded that reported effects for endpoint 52 were a 50% decline in 14C uptake and the biomass of phytoplankton, with recovery to control levels taking longer than 3 weeks. Ultimately, EPA kept the change to effect for endpoint number 52 and made no changes to the 1979 University of Kansas endpoints. After the release of the risk assessment, and then again in 2022, EPA received comments, which reiterated much of what was said in the past, included restated suggestions to change the effect no effect conclusions of endpoint number 52, plus new concerns about the splitting of endpoints. So now finally on to EPA's 2023 reevaluation. Based on past concerns and criticisms, as well as EPA's reevaluation, EPA identified 3 determinative concerns: the fish in the ponds and their impact on the aquatic plant community, the splitting of endpoints, and the effect, no effect conclusions. First, I'm going to discuss the fish in the ponds. As a reminder, the 1979 University of Kansas experiment only had bluegill sunfish, gizzard shad, and channel catfish. The SAP said COSMs incorporating fish should be of sufficient size as to allow robust growth of fish without excessive interspecific competition that will substantially alter plant communities, and cited 2ART 1988. 2ART 1988 indicates that densities within the range of 2 to 5 grams per cubic meter are appropriate. And so based on this information, the experimental ponds used in the 1979 experiment could support 940 to 2,350 grams of fish biomass. Unfortunately, the publications associated with the 1979 experiment provide no data on the initial mass of the fish, only the total numbers of each species. However, we can get an idea of the initial fish biomass in the 1979 experiment because in the 1981 to 1983 experiment that we'll discuss in the next presentation, mean initial starting mass of the fish is available. In 1981, the total starting biomass was approximately 602 grams based on the number of fish and their individual mean masses, which is below the lower end of the range calculated based on 2ART 1988. Fish in the 1979 experiment were longer than those in 1981, but it's unlikely that a difference of 2 to 3 centimeters would result in a total biomass that exceeded the upper end of the range. Additionally, there were 3 less gizzard shad in 1979, which were the fish with the largest mass. Therefore, the initial biomass of the fish was likely within the range presented in 2ART 1988 citation, which was cited by the 2012 SAP. It's expected that there will be changes in total biomass over time during long-term community experiments. The remaining concern is that natural changes and treatment-related changes could result in exceeding the biomass limits and differing community impact. The results we assessed occurred within the first months of the experiment, so it's unlikely that biomass due to natural changes exceeded the upper range calculated based on 2ART this quickly. The remaining uncertainty is differing community impacts due to differing treatment-related changes. If we look at metrics that make up biomass, we see that in the atrazine treatments, growth decreased by 16 to 31%, reproduction in the bluegill only decreased by 96%, and there were no effects on survival. The difference in growth and reproduction could represent confounding effects, but let's look at some of the expected versus observed direct and indirect effects from these changes. First, the bluegill biomass, which are zooplankton and insect predators. Their biomass likely varied the most because of effects on both growth and reproduction, and that could have had indirect effects on phytoplankton. For example, in the 500 microgram per liter treatment, we would expect that a reduction in fish biomass would result in an increase in zooplankton due to the decrease in consumption by the fish. And because of the now increase in consumption by the zooplankton, there would be subsequent decreases in phytoplankton if fish were the only factor impacting these parameters. However, what was seen was lower fish biomass and a decrease in zooplankton that followed a decrease in phytoplankton. The decline in zooplankton was attributed to a decline in food or the phytoplankton due to direct atrazine effects on the phytoplankton. For other species of fish, which are benthic and filtering omnivores, they might cause direct impacts to phytoplankton and microphytes. In the 500 microgram per liter treatment, we would expect a reduction in fish biomass due to the decrease in growth and therefore an increase in phytoplankton and macrophytes if fish were the only factor impacting these parameters. However, what was observed was a decrease in both phytoplankton and macrophytes despite the reduction in fish biomass. While there could have been other indirect effects, such as from waste production, these 2 examples indicate that there were likely also direct atrazine impacts to primary producers in the ponds. Therefore, EPA has decided to keep the University of Kansas 1979 endpoints in the COSM database. Next, I'll present on concerns about splitting endpoints. So first, EPA supports the combining of different aquatic plant community parts so that the community is represented by a single endpoint. However, concern was that EPA inconsistently included more than one endpoint per treatment, as opposed to having one endpoint per treatment to represent the whole plant community. For example, endpoint number 52 was for the 20 microgram per liter treatment with the plant group phytoplankton, while endpoint number 2 was for a 20 microgram per liter treatment with the plant group macrophytes. However, if we look at the duration and comment columns in the COSM database, we see that endpoint number 52 was for the 1979 experiment, while endpoint number 2 was for the 1981 to 1983 experiment. A similar case applies to endpoint number 3, a 500 microgram per liter phytoplankton and macrophyte endpoint, and then endpoint number 1, a 500 microgram per liter macrophyte endpoint. Looking at the duration and comment columns shows that they are also from 2 different experiments. Therefore, EPA did not split the endpoints from the 1979 experiment. Finally, I'll present on the effect, no effect conclusions. So first, we're going to look at the macrophyte results. For endpoint number 52, 20 micrograms per liter, the macrophytes were visually reduced but did survive. Some publications say by 50%, others by 60%, and others by 90%. For endpoint number 3, 500 micrograms per liter, various publications say that 90 to 100% of the macrophytes died. Overall, some publications mention that these percents were verified by rake hauls and aerial photos. However, there are no figures or tables that present the results. EPA has decided that the macrophyte results are not sufficient to make an effect, no effect conclusion due to the lack of quantification and presentation. Next, we'll look at the phytoplankton results. The results include biomass assessed via chlorophyll A, biomass measured via particle counts, and carbon-14 uptake. All graphs have measurements on the y-axis and time and days on the x-axis. The treatments are represented by the same symbols and lines in each graph, with the control being a solid line with an open circle, the 20 microgram per liter treatment being a dashed line with a closed circle, and the 500 microgram per liter treatment being a dashed line with a closed triangle. First, I'll go over endpoint number 52, the 20 microgram per liter treatment, which is represented by the closed circles. For chlorophyll A biomass, 20 microgram per liter treatment and the controls were pretty similar early on. From day 20 to about day 90, the 20 microgram per liter treatment was actually greater than the control. For particle count biomass, the control and the 20 microgram per liter treatment were pretty similar throughout the experiment. And then for carbon-14 uptake, the control and 20 microgram per liter treatment followed the same patterns again. Based on the 2023 reevaluation, EPA has scored this endpoint as no effect, given the considerable overlap with the control and the phytoplankton results. And again, the macrophyte results were not considered sufficient to make an effect, no effect conclusion due to the lack of quantification and presentation. This endpoint was previously scored as an effect. Next, endpoint number 3, or 500 microgram per liter treatment, which is represented by the closed triangles. For chlorophyll A biomass, the 500 microgram per liter treatment initially drops while the control stays pretty steady. From about day 20 to the end of the experiment, the control and 500 microgram per liter treatment are similar. For particle count biomass, the 500 microgram per liter treatment also drops, rises, and then drops again for the remainder of the experiment, while the control stays pretty constant. Finally, for carbon-14 uptake, the 500 microgram per liter treatment also drops, rises, and then drops again for the remainder of the experiment, while the control stays pretty constant minus the initial peak at the beginning. Based on the 2023 reevaluation, EPA has scored this endpoint as effect, given the sharp and prolonged decline in phytoplankton. And again, the macrophyte results were not considered here due to the lack of quantification and presentation. To add further support to these conclusions, I'll present species-specific results here with species on the y-axis and time and day again on the x-axis. So endpoint number 52 has been scored as no effect in the 2023 reevaluation. At the species level, we see trends in the 20 microgram per liter treatment that are similar to the control. For endpoint number 3, which has been scored as effect in the 2023 reevaluation, species distributions in the 500.
Hey, good morning, Ms. Giles. This is Brandon Cook, Commercial
I'm
Bank.
sorry, Linda, could you please mute your line? Thank you. Excuse me. Okay, we're ready to go.
Okay.
Thank you.
Yep, so I'll repeat that. So for endpoint number 3, which is scored as an effect in the 2023 reevaluation, species distributions in the 500 microgram per liter treatment showed initial declines to 0 when compared to the control treatment. So finally, I'll present on EPA's 2023 conclusions. Here's the figure I presented earlier. As a reminder, we originally had 2 endpoints for the 1979 University of Kansas experiment, both of which were scored as an effect. After the 2023 reevaluation, we still have 2 endpoints, although their plant groups have been adjusted to represent the groups assessed in the reevaluation. For the effect, no effect conclusions, endpoint number 52 has now been scored as no effect, while endpoint number 3 will remain as an effect. This brings us to the charge of the panel for this presentation, which is question number 2. Please comment on EPA's decision to include the 1979 University of Kansas study group and update the effect, no effect conclusions for the 2 included endpoints. Do you have any questions for clarification?
Clarifying questions from the panel? All right. I'm not seeing any hands coming up.
Yes, I don't see any hands. I do see one. I'm sorry, Dr. Murphy.
I have a question. So we see the decline in the so like at the 500 microgram per liter, you see the decline, and then you see it go up, and then it comes down again. There's no other evidence to suggest why you would see that mechanism.
I had to return to the publications, but I don't recall anything in the publications explaining that pattern.
Thank you.
Okay, I guess we're done. 81 to 83, Kansas.
Okay. That is me again. Okay. So good morning again. So for those of you that weren't in attendance of the last presentation that just happened, my name is Kayla Coldsnow and I'm a biologist in the EFED. This presentation will be a high-level overview of EPA's review of the University of Kansas 1981 to 1983 experiment study group, which represents several open literature publications under consideration that describe the effects of atrazine exposure to aquatic plant communities. A more in-depth discussion is provided in the white paper. This presentation will follow the same outline of the previous presentations, including an overview of the study, major concerns and criticisms, and EPA's 2023 reevaluation. So first, an overview of the experiment, including what publications went into the reevaluation and how the 2 University of Kansas experiments are connected. As I mentioned in the last presentation, there were 2 atrazine experiments completed at the University of Kansas, with one occurring in 1979, which was the last presentation, and then one occurring from 1981 to 1983, which will be this presentation. And again, the 2012 SAP had concerns with 5 publications associated with these 2 experiments. 3 of these publications present the 1981 to 1983 experiment, Carney 1983, Dewey 1986, and Denoyles et al. 1989. In addition to these publications, 5 additional publications discuss the 1981 to 1983 experiment. And these include Denoyles and Kettle 1983, Denoyles et al. 1994, Huggins 1990, and Huggins et al. 1994. Larson et al. 1986 also. These all discuss methods and results associated with the 1981 to 1983 experiment, and were included in the 2023 reevaluation. Similar to the white paper in the last presentation, the publications will be discussed collectively, with separation only when relevant in this presentation. So before jumping into the 1981 to 1983 University of Kansas experiment, I think it's important to first connect this experiment to the one completed in 1979, which was the last presentation. The 1981 to 1983 experiment used many of the same experimental ponds as the 1979 experiment, which are represented here with the teal shapes overlaid on a figure from one of the publications. As a reminder, the 1979 experiment consisted of 2 control ponds, 2 20 micrograms per liter ponds, and 2 500 microgram per liter ponds. In 1981, 2 newly constructed ponds were set up as a control pond, and 4 newly constructed ponds were dosed to be 20 microgram per liter treatments. 2 of the previously used ponds on the west side of the field were dosed to be 100 micrograms per liter. And then finally, 1 pond was dosed to be 100 micrograms per liter, and another was dosed to be 200 micrograms per liter, which is denoted as 100/200 because it's unknown to the reader which pond received which treatment. While the water and therefore plankton, potted macrophytes, and fish were removed and new were added between the experiments, EPA believes that the sediment and non-potted macrophytes were not entirely removed and replaced between experiments because the publication states that the ponds had developed similar though sparse macrophyte communities. Therefore, it was deemed unnecessary to actively seed them with macrophytes for the 1981 to 1983 experiment. Therefore, the 1981 macrophytes populations would have been based on macrophytes from prior years. It's important to note, though, that the 1981 treatments were only applied to the 1970 ponds that had no or low atrazine. And I'll talk about the subsequent changes to the ponds that occurred in 1982 in a few slides. So next, I'm going to go over how the 1981 to 1983 University of Kansas experiment was completed. In the 1981 to 1983 experiment, the large experimental ponds contained 470,000 liters of water. The water was 2.1 meters deep. Plankton, which came into the water, bluegill sunfish, channel catfish, and gizzard shad, which will be relevant near the end of this presentation. In 1982, the second year of the experiment, grass carp were added. Potted Nyja and Cara macrophytes were also added in year 2, and then other plants and animals were also present, likely from natural colonization. Commercial grade and reagent grade atrazine were used to dose the ponds. And during each redosing, which I'll discuss next, pond water levels were brought back up to 2.1 meters. So as far as the experimental treatments, for year 1, 1981, there were 6 treatments replicated 1 to 2 times, and the atrazine used was reagent grade or RG and commercial grade or CG. The treatments included control or 0 micrograms per liter, which was replicated 2 times, 20 micrograms per liter with reagent grade replicated 2 times and commercial grade replicated 2 times, 100 micrograms per liter with reagent grade replicated 2 times and commercial grade replicated 1 time, and 200 micrograms per liter replicated 1 time involved a dose with both reagent grade and commercial grade atrazine. For year 2, 1982, there were 5 treatments replicated 2 times, all with reagent grade atrazine. To get the year 2 treatments, some year 1 treatments were changed, but always to higher concentrations, never to lower concentrations. So the control pond stayed the same. The reagent grade 20 microgram per liter and 100 microgram per liter ponds stayed the same. The single commercial grade 100 microgram per liter treatment and the 200 microgram per liter treatment were redosed to be 200 micrograms per liter. And then finally, the commercial grade 20 microgram per liter treatment was redosed to become a 500 microgram per liter treatment. For year 3, 1983, all the ponds were redosed to be the same as year 2. And then finally, the experiment ended in late 1983. Throughout the experiment, many abiotic and biotic parameters were sampled. And then for this presentation, only the measured endpoints representing the aquatic plant community will be discussed. For the aquatic plant community, phytoplankton and macrophytes were sampled. The phytoplankton samples and results were unclear across the publications. Carney, 1983, only mentions chlorophyll A briefly. Denoyles and Kettle, 1983, mentions assessing resistance using fluorescence and carbon uptake with additional atrazine added to the samples to elicit response and measure tolerance. Denoyles et al. 1989 implies that the fluorescence and carbon uptake were assessed both with and without additional atrazine. However, this publication is vague in spots because it's presented on both University of Kansas experiments. Results are limited to only a few treatments, and it's often hard to separate the 2 experiments. For the non-potted macrophytes, 10 rake samples were collected per pond and then rated on a scale of 0 empty rake to 4 maximum capacity. And then samples were separated by species and were rated again. These samples were only collected once in year 1 and then multiple times in June and September of year 2 and 3. In year 2 of the experiment, there was an in situ experiment with potted Nyja and Cara, where 2 baskets of plants were added to a single 0, 20, 100, and 500 microgram per liter pond, and then they were assessed the relative growth or the number of nodes per segment. They're not included in this reevaluation because having 2 independent replicates was a requirement. Finally, emergent macrophytes were assessed in year 2 and 3 by counting the number of leaves. And there were also mentions of aerial photographs. In addition to biotic measurements mentioned here, atrazine concentrations were also measured and will be discussed later in the reevaluation section. For the statistics, in Denoyes et al. 1989 publications indicate that data were analyzed using analysis of variance ANOVA, but as a reminder, there were only 2 replicates most of the time. So now that I've given an overview of what publications are included in this group and went over the experiment, it's now time to go over how EPA used the study most recently in the 2016 Refined Ecological Risk Assessment. So to discuss the cause and database in 2016, I'll show the figure I showed earlier when discussing the experimental treatments. For the 1981 to 1983 experiment, there were 6 endpoints that were all classified as effects. Endpoint number 2 represented the 20 microgram per liter treatment from year 1 and had a plant group of macrophytes. Endpoint number 4 represented the 100 microgram per liter treatment from year 1 and had a plant group of macrophytes. Endpoint number 41 also represented the 100 microgram per liter treatment from year 1 and had a plant group of phytoplankton. Endpoint number 42 represented the 200 microgram per liter treatment from year 1 and had a plant group of phytoplankton. For year 2, endpoint number 5 represented the 200 microgram per liter treatment and had a plant group of macrophytes. And finally, endpoint number 1 represented the 500 microgram per liter treatment from year 2 and had a plant group of macrophytes. As you can see, the endpoints have different plant groups, which will be addressed at the end of this presentation. So the way EPA used the 1981 to 1983 University of Kansas experiment brought about concerns and criticisms, which I'll discuss next. For the 2009 SAP, the SAP commented on the effect, no effect conclusions of endpoint number 2, which was a 20 microgram per liter treatment, and said that these studies should be closely evaluated. For the 2012 SAP, during the public comment period, comments suggested that endpoint number 2 should be rescored as no effect. However, there was some confusion about which publications were associated with the 1981 to 1983 experiment, which is likely because EPA incorrectly associated publications with endpoint number 2. As mentioned in the last presentation, one comment went on to conclude that COSM studies at the University of Kansas at Lawrence were the most ambitious ever conducted with atrazine in terms of size and complexity of experimental ecosystems. In the minutes, the 2012 SAP commented on 3 publications associated with the 1981 to 1983 experiment: Carney 1983, Denoyes et al. 1989, and Dewey 1986. The comments questioned the observed effects at lower concentrations, especially the 20 micrograms per liter treatment, and then that there were other stressors present, meaning the fish. Specifically, there were concerns about fish abundance, survival, reproduction, and the presence of carp, which were present in the 2nd and 3rd year of the 1981 to 1983 experiment. The panel also noted that these publications represent publications discussed by the 2009 SAP as having flawed methodology, which affected the interpretation of the results. They also said these publications were considered ecological classics based on the hypotheses tested, study complexity, and ecological relevance. However, they were not conducted under any semblance of good laboratory practices, or GLP. And again, it's rare for open literature experiments to be conducted under GLP, and the experiments were not required to be conducted under GLP. In the 2016 Refined Ecological Risk Assessment, EPA addressed the 2012 SAP recommendation to limit the data to realistic durations by selecting a duration limit of 240 days for the maximum length of the study. However, EPA did not remove any endpoints from the 1981 to 1983 University of Kansas experiment. EPA reevaluated the 1981 to 1983 University of Kansas group and concluded that reported effects for endpoint 2 included only the first year, where no recovery was reported and there were biologically significant decreases in plants. Ultimately, EPA made no changes to the 1981 to 1983 University of Kansas endpoints. After the release of the risk assessment, and then again in 2022, EPA received comments which reiterated that what was said in past, including restated suggestions to change the effect, no effect conclusions for endpoint number 2, plus new concerns about the splitting of endpoints. So now finally on to EPA's 2023 reevaluation. So for this presentation, I'm going to provide a endpoint tracker on the right side of every slide in the reevaluation section because of the complexity of this group. Endpoints will be outlined in gold when they're relevant and grayed out when they're removed. Based on past concerns and criticisms, as well as EPA's reevaluation, EPA identified 5 determinative concerns for the 1981 to 1983 University of Kansas group: the experiment duration, the fish in the ponds and their impact on aquatic plant communities, the splitting of endpoints, treatment replication, and the effect, no effect conclusions. So first, I'm going to go over the experiment duration. So as I said earlier, after the 2012 SAP, EPA set a duration limit of 240 days to represent a more realistic exposure duration and applied this limit to all COSM studies in the database. This limit was relevant to the 1981 to 1983 University of Kansas experiment, to which EPA said the effects noted in these studies were initially reported within the first few days to weeks following atrazine introduction into the mesocosms. However, as these effects were occurring throughout the study, these endpoints were not removed from the COSM endpoint database. During the 2023 reevaluation, EPA noticed 2 endpoints from year 2, or 1982, that remained in the COSM database, endpoint number 5 and endpoint number 1. During the reevaluation, EPA considered keeping these endpoints and even thought about adding more from year 2 and year 3 if the atrazine degraded to approximately control levels over the course of the year, giving the community time to recover prior to the redosing. In this figure, atrazine concentrations are on the y-axis on a log scale, and then time in days is on the x-axis. This is what the atrazine concentrations look like over time. During year 1, atrazine concentrations decreased after the initial dosing to approximately 7 micrograms per liter in the lowest 20 microgram per liter treatment. All others stayed around or above approximately 30 micrograms per liter, which is higher than the lowest concentration tested. Similarly, during year 2, atrazine concentrations decreased to approximately 4 micrograms per liter in the lowest treatment. And all others stayed at or above 20 micrograms per liter, which is again the lowest concentration tested. So atrazine concentrations did not decrease to 0 micrograms per liter before the next dosing, and atrazine concentrations remained elevated for all 3 years of the experiment. Therefore, EPA is removing year 2 endpoints because the community would have been exposed to atrazine for more than 240 days. Some year 1 1981 endpoints will remain in the database because effects occurred during the first few months of the experiment. Next, I'm going to present on the concerns about fish in the ponds. As mentioned earlier, bluegill, gizzard shad, and channel catfish were present in the 1981 to 1983 University of Kansas experiment. In year 2 of the experiment, grass carp were also included and were perhaps the largest concern of the 2012 SAP. However, because only endpoints from year 1 will be included, the grass carp added in year 2 are no longer a concern. There could still be concerns about the other 3 fish species, including the initial biomass and change in biomass over time. As mentioned in the last presentation, the 2012 SAP cited Tuart 1988, who says densities within the range of 2 to 5 grams of per cubic meter are appropriate. Therefore, the experimental ponds could have supported 940 to 2,350 grams of fish biomass. One publication from the 1981 to 1983 experiment provides the mean initial starting mass of the fish. Therefore, this total starting biomass was approximately 602 grams, which is less than the range calculated based on Tuart 1988. And EPA is therefore not concerned about the initial biomass. Again, it's expected that there will be changes in total biomass during a long-term community experiment. The remaining concern is that natural and treatment-related changes could result in exceeding the biomass limits and differing community impacts. The 2012 SAP had concerns about gizzard shad survival. This concern likely originated from a graph from Denolis et al. 1989, which shows gizzard shad biomass from year 3 on the y-axis and atrazine concentrations on the x-axis to the right. The specific concern was about low gizzard shad survival in one of the controls. But since this is from year 3, this would not be a representative of the fish in year 1. For the 1981 to 1983 experiment, EPA did not come across a publication that indicated survival, growth, or reproduction for year 1, which is because the samples would not have been taken until the end of the experiment in 1983. However, we can look back at the 1979 experiment to get an idea about what could have happened, since the 1981 to 1983 results we assessed occurred on a similar time frame. So for example, survival of the stockfish in 1979 experiment was high and unaffected by the treatments. There were impacts on fish growth and reproduction in 1979, but the impacts on zooplankton in the aquatic plant community was opposite what one would predict if fish were the cause. During year 1 of the 1981 to 1983 experiment, there were minimal, if any, impacts on zooplankton, and the effects on the aquatic plant community are those one would predict if atrazine was the cause. Therefore, EPA has decided to keep the University of Kansas 1981 to 1983 endpoints, the 1981 portion only, in the database. So next I'm going to present on the concerns about splitting endpoints. So as a reminder, the concern was that EPA inconsistently included more than one endpoint per treatment, as opposed to one endpoint per treatment to represent the whole plant community. After the discussion of endpoint number 2 in the last presentation, where I showed that it's indeed a separate endpoint, and then the removal of endpoints number 5 and number 1 earlier in this presentation because they're from year 2 of the experiment, we are left with 2 endpoints that have the same concentration and need to be further investigated. Endpoint number 4 was for a 100 microgram per liter treatment with the plant group macrophyte, while endpoint number 41 was for a 100 microgram per liter treatment with the plant group phytoplankton. Looking at the duration and comment columns in the COSM database shows that they are from 1981, they're both from 1981, year 1 of the experiment. This is an error in the database, as there should only be one endpoint per treatment. Therefore, EPA has decided to remove endpoint number 41 from the database, so there will only be one endpoint, number 4, representing the 100 microgram per liter treatment. So next, I'll present on the final issue regarding the number of endpoints, treatment replication. This issue was not brought up by past SAPs or during public comments. However, EPA noticed that endpoint number 42 was associated with a 200 microgram per liter treatment from year 1 of the 1981 to 1983 experiment. This treatment only had a single replicate. The study acceptance criteria states that at least 2 replicates per treatment and controls must be included regardless of the statistical method used. Therefore, EPA has decided to remove endpoint number 42 from the database because it only had 1 replicate. The final concern I'll present on is the effect, no effect conclusions for the 2 remaining endpoints. As a reminder, for phytoplankton, many of the publications mentioned that measurements involved a second dose of atrazine to measure tolerance. Therefore, most publications only present treated samples. The Denoyles et al. 1989 public paper hints at there being an untreated sample by saying atrazine tolerance for phytoplankton communities from the experimental ponds and other ponds was measured by incubating water samples containing phytoplankton for 24 hours with and without a further addition of 100 micrograms per liter of atrazine. However, for year 1, only the 100 microgram per liter treatment results are presented, which shows that the control was relatively constant over the first 20 days of the experiment, while the 100 microgram per liter treatment was pretty consistently below the control during the middle part of the 20 days. The text states that phytoplankton declined at all concentrations during the first 3 weeks of exposure, with a return to control pond levels thereafter. The study also indicates that the decline at 20 micrograms per liter was statistically significant, but not as severe as a complete cessation of carbon uptake at the higher concentrations. But there was no presentation of the 20 microgram per liter results. And so now I'm going to move on to the macrophyte results. It's important to first note a few things. First, year 1 macrophyte results do not distinguish between reagent grade RG and commercial grade CG treatments. This is likely because there were no differences, which was mentioned in several of the publications, and the results were aggregated. As a reminder, there were 2 reagent grade replicates and 2 commercial grade replicates for endpoint number 2, and there were 2 reagent grade replicates and 1 commercial grade replicate for endpoint number 4. For year 1, there was only a single sampling in September. However, the 1981 to 1983 experiment methods were more robust than the 1979 experiment, and results included graphical representation and to assess the data variability. So for the macrophyte results, I'm going to show this figure that represents the results from September 1981, year 1. On the x-axis is atrazine concentrations, and then on the y-axis is the macrophyte score. It's worth pointing out the numbers on the y-axis. As I said, samples were rated from 0 to 4. However, there were 10 samples per pond, and the scores of those samples were added together so that the total score per pond could be from 0 to 40. Panel A shows the overall score of the ponds, while panel B shows the score after the samples were separated into two different groups of macrophytes, vascular and charophytes. For the 20 microgram per liter treatment, or endpoint number 2, by September 25th, 1981, this treatment had a floral community composed mainly of vascular species like the control, which can be seen in panel A with the overlap with the control, and panel B with the similar levels of vascular plants and overlap with charophytes. Based on the 2023 reevaluation of the phytoplankton and macrophyte results, EPA has scored this endpoint as no effect. It was previously scored as an effect. For the 100 microgram per liter treatment, or endpoint number 4, by September 25th, 1981, the total macrophyte cover was similar to the control, but the composition was mainly charophytes, which can be seen in panel A with the overlap with the control, but panel B shows a flip in the plant composition. Based on the 2023 reevaluation of the phytoplankton and macrophyte results, EPA has scored this endpoint as an effect. So finally, I'm going to present EPA's 2023 conclusions. So here's the figure I presented earlier. As a reminder, we originally had 6 endpoints for the 1981 to 1983 University of Kansas experiment, all of which were scored as an effect. After the 2023 reevaluation, we have removed 4 endpoints. The 2 endpoints that remain are endpoint number 2 and endpoint number 4. Endpoint number 2, the 20 microgram per liter treatment, will be scored as no effect, while endpoint number 4, the 100 microgram per liter treatment, will remain as an effect. For both endpoints, the plant group will be phytoplankton and macrophytes to represent the groups assessed in the reevaluation. And so this brings us to the charge to the panel for this presentation, which is question number 3. Please comment on EPA's decision to include the 1981 to 1983 University of Kansas study group, but exclude 4 endpoints and update the effect, no effect conclusions for the 2 remaining endpoints. Any questions for clarification?
Okay, clarifying questions from the panel.
Dr. Chapin, there's Dr.
Yep.
You see, Dr.
Got it.
Felsen.
I see. Yep. Dr. Felsad.
Yeah, thank you. I'd like to get some clarification on volume changes in these. My understanding that there's no added water to these during the experiments. Is there any way to, or did you try to get volume change information so you can actually know what's the actual volumes, not the initial volumes?
Yeah, so in the 1981 to 1983 experiment, they were brought back up to the 2.1 meters every year, but during the 1 year, they were not adjusted, except for from precipitation and then evaporation would be affecting them. I can't recall, I know in one of the experiment sets, they had mentioned how much the water had went down during that time. And I believe it was pretty significant. Like I would say, I don't want to quote the exact number because I'm not aware of that one. But again, these results that we looked at were within the first couple months of the experiment. So the experiment started in around May or June. And then by September is when the results were from, as opposed to waiting all the way until the following year when they would have been at their lowest likely in April.
Do you consider then that the prolonged persistence is related to decreasing volume relative to time?
I'm not as familiar with this.
Hi, this is Frank Ferrugia. Could you repeat that question for me one more time?
Yeah, I'm struck by the prolonged persistence when you show the persistence graphics. Have you thought about whether the persistence is due to the decreasing volume and a very slow degradation rate, or you just expect it to be at those levels in a natural system?
No, I mean, I think that's what we've seen in atrazine concentrations when you do have a static system, is that it's fairly persistent. There's likely degradation occurring in there. I think partially because we don't have the total volumes at the end related to those concentrations, it certainly is likely that some of that elevated concentration at the end of the duration of each year is contributed by the volume changes. So yeah, I mean, it shows fairly stable and fairly uniform declines across all the systems. And I think that's notable. That exposure had existed, and that exposure was basically within an order of magnitude across the full duration of the study. So
thank you.
Yep.
Dr. Farrell?
I was wondering if I could get clarification on the macrophyte part of this study. So we do have data of a decline in macrophytes post-treatment, but they had indicated that these were sort of naturally occurring. Do we have any information from each of those ponds before they treated about the species that were there and the density of those species in those ponds?
I can't recall that information. It might be hidden in University of Kansas literature and stuff, but not in the publications that we assessed.
Okay, Dr. Chen?
Yeah, I was just wondering if you could give some clarification on the removal of the endpoint 41. Are you just eliminating all the information from phytoplankton, or are you actually merging the information from these two endpoints to endpoint number 4? Because for your figure 4.4 on the chapter 4 there, when you do the effects, whatever determination, that graph is about phytoplankton carbon-14 uptake. So I'm just wondering about that.
Yeah, so for the 1981 to 1983 experiment, we did combine the endpoints 4 and 41 to be a single endpoint of number 4. And that number 4 endpoint will represent the phytoplankton and the macrophyte communities combined. So we were able to look at the results for both of those for the 1981 to 1983 experiment.
Thank you.
Good. Okay. All right. Any other questions for clarification? So we've got, it's about what, 12 or 13 minutes until noon.
Yes.
Tamu, you want to, let me see, I guess, so the next up is lunch at suggested 12:05. My thought is that if people would be amenable, I'm thinking, why don't we go ahead and have the Dettenbeck presentation from Frank.
Are we ready for that, Dr. Tamuji, are you ready for the Dettenbeck study?
Yes, we can do that. It's a fairly short one, so we won't keep your stomachs growling.
That was my thought.
Oh, good. Great. Thanks, Dr. Chapin. Okay. While we're setting up, very well, that's good.
Okay, thank you all. I'm Frank Ferrugia. I'm a senior advisor in the Environmental Fate and Effects Division. And I'm here to present on the Dettenbeck experiment, which was discussed in chapter 5 of the white paper. The outline for this talk is the same as the other talks we've presented today. We'll start with the overview, go through some experimental design conversation, previous interpretation by EPA, and present the concerns raised by public commenters in SAP and end with EPA's 2023 conclusions. The Dettenbeck experiment is represented by a single publication. It was first included in EPA's COSM database in 2003. EPA's interpretation of the experimental results identified effects at all tested concentrations, and EPA has been consistent from 2003 through 2022 with the identification of effects in this study. Chapter 5 of the white paper provides a description of the study design and the reported results that are relevant to the determinative concerns from the SAP and the public, and concludes with EPA's 2023 reevaluation and conclusions. So now let's get down into how the Dettenbeck experiments were completed. The experiment was conducted at the EPA Monticello Ecological Research Station in Monticello, Minnesota. The wetlands were constructed in 1987 by diverting about 90% of the flow from the lower portion of existing experimental streams that were fed by water source from the Mississippi River. Each mesocosm was a 203-meter long flow-through system constructed to have 4 30 by 30 meter by 3 meter by 80 centimeter pools and 4 30 meter by 2 meter by 15 centimeter shallow riffle zones in alternating sequence. Within the cosms, the study authors planted cattail and wild rice, and all other plant and animal taxa within the cosms were naturally occurring. Naturally occurring taxa colonized the cosms prior to and during the experimental phase of the study. And these taxa included emergent, submerged, and floating macrophytes, phytoplankton, and periphyton, as well as animals. It is unclear how long the cosm studies were allowed to establish prior to the experimental phase of the study, and pre-experimental community descriptions were not provided. For each of the controls and treatments, there were 2 replicate cosms. Commercial grade atrazine was dissolved in well water to make a stock solution, and the study was silent on how the stock solution was added to the treatment cosms. The reported measured concentrations in the cosm effluent and cosm sediments are relatively stable for the flow-through systems, and support EPA's assumption that the stock solution was added to the cosms continuously over a duration of the exposure phase. The atrazine treatments were given as a stepped exposure regime. That is, the test cosms were given progressively increased concentrations over time, as shown in the figure here. The first exposure was 15 micrograms per liter that lasted for a duration of 15 days from mid-May to June. The concentration was then increased 25 to 25 micrograms per liter for 44 days from throughout June and to mid-July. Then the concentration was again increased to 50 micrograms per liter for 33 days until mid-August. And lastly, the final concentration of 75 micrograms per liter had a duration of 18 days, and exposure phase of the study ended on September 4th. Periphyton productivity was assessed using acetate strips that were placed into the cosms and allowed to colonize for 9 to 27 days. The exact durations of the strips that the strips were in the cosms were not specified. Based upon the reported results in 2016, EPA assumed that the strips were placed during each of the concentration treatment test levels and then were removed prior to the next atrazine dose increase. There were several measures of productivity of the cosms reported for both periphyton and macrophytes, including growth, chlorophyll A, net primary production, and gross primary production. Now I'm going to switch and discuss how the EPA used this study, most recently in the 2016 ecological risk assessment. In 2016, EPA included Dettenbeck in the COSM database with effects limited to those related to the periphyton strips that were added at the start of each study's phase. Other reported effects in the study, such as macrophyte results, were determined by EPA as unreliable because the endpoints were not discrete to individual exposure concentrations, and the durations of exposure were unclear. This is especially true for the macrophytes that were not deliberately added to the cosms. This was responsive and in agreement with the 2012 SAP comments on the study. Endpoints were assigned to each of the tested concentrations in the first stage of the study. Treatment cosms received 15 micrograms of atrazine corresponding to endpoint 22 in the atrazine cosm database. Periphyton results for endpoint 22 identified a 23% reduction in dissolved oxygen. and statistically significant reduction in gross productivity relative to controls. Endpoint 23 represented a second stage with increased atrazine concentrations to 25 micrograms per liter, and EPA based the effects call on the reported statistically significant reductions in respiration and net primary productivity relative to controls. Endpoint 24 represented the third stage, which tested 50 micrograms per liter and reported statistically significant reduction in net primary production. And lastly, the final stage of the study, endpoint 25, tested 75 micrograms per liter and resulted in statistically significant reductions in net primary productivity. Based on these findings in 2016, EPA maintained the effect determination for each of the 4 endpoints in this study. The way EPA used the Dettenbeck experiment brought out concerns and criticisms, which I will discuss next. As mentioned earlier, in the 2012 SAP, had concerns with the Dettenbeck study, and based on these concerns, the SAP recommended removing the Dettenbeck study endpoints from the COSM database. The SAP noted that there were study design and reporting concerns. The SAP points out that the authors did not provide information on the initial pre-exposure communities. Therefore, it was unclear how each of the COSMs compared across treatments and controls prior to the introduction of atrazine. Additionally, Dettenbeck reported that an abundance of organic matter had accumulated in the COSMs prior to exposure. The SAP concluded that gross photosynthesis was likely not reliable based on the likely decay of the accumulated organic matter. The SAP also pointed out that there was no observed effect on chlorophyll A or dry weight, and that macrophytes were not impacted up to 75 micrograms per liter, the highest tested concentration. Similar comments were raised by the public. As mentioned earlier, based on the feedback from the SAP in 2012, in 2016, EPA narrowed its consideration of the effects in the study to those reported on the periphyton strips. This was because the strips were reportedly added and then removed in short intervals associated with individual dosing stages of the experiment and were unlikely impacted by the concerns raised by the SAP. EPA concluded in 2016 that the concerns identified by the SAP were not relevant to the periphyton responses and were not impacting the interpretation of these study results. Based on this conclusion, the study remained in EPA's COSM database in 2016, and as discussed before, were classified as effects. Because of EPA's narrow focus on the reevaluation in 2016, the review missed an important aspect of the study design relevant to the concerns raised by the public, and upon further consideration, EPA believes this to be potentially impacted the interpretation of the periphyton results as well. The public identified concerns about the stepwise exposure method and the impact that this had on the interpretation of the exposure response relationships. The public had also raised concern that there were only 2 replicates, and in some endpoints, there was a high variability between the treatment replicates. Lastly, there were public comments stating that some endpoints were unreliable based upon the reported effects at low concentrations that were not observed in a dose response manner, and that were often only qualitative statements about observed effects. So now I'm going to switch gears and talk about our reevaluation. Based upon the past SAP and public concerns and criticisms, as well as EPA's reevaluation, EPA identified 2 determinative concerns. The study design, in particular, the stepwise exposure design, the study design, which was particularly issued around the stepwise exposure design, and unreliable endpoints as they were associated with manipulations made during the experiment. To start with the stepwise exposure, the concern is that treatments were not independent from each other. Because the study design increased the test concentrations every few weeks, and because the stepwise approach, each new treatment occurred on a community with a prior exposure history. While periphyton strips were added during each phase of the study, they were colonized by periphyton that was already present in the COSMs and had prior exposure of atrazine. Because of the sequential addition design, the study was conducted over a period of a few months. Because of natural succession of the communities, the periphyton in the different treatment concentrations were likely not reflective of equivalent communities of earlier exposure time periods and may have reflected an increasingly tolerant periphyton taxa over time. Therefore, comparisons between different stages of the studies are not reliable. For instance, as mentioned in the public comments, there was an observation of effects at low concentrations that were not observed at higher concentrations. This could be solely a result of the sequential design and not atrazine, or it could have been related to some combination of these factors. Additionally, EPA reconsidered the reported timing of the periphyton strips, experimental exposure, and their observations. Exposure durations for observed effects were not clear in the study. Most effects were reported, including those for periphyton, are reflective of full duration of exposure treatments at each stepwise exposure. And it's not clear if, on some occasions, the next sequential atrazine addition was added to the mesocosms before the measurement of the effects were made and potentially before the biological samples for measurement were collected. Lastly, the multiple manipulations of study of the design and uncertainty due to the lack of information reported is an issue. Several separate sub-study experiments were carried out within and throughout the conduct of the primary experiment described above. These manipulations included removal and addition of components of the cosms, such as the addition and removal of plants in various nutrient pots. It is unclear how these may have impacted the interpretation of the primary study. Finally, I'll present EPA's 2023 conclusions. Based on the issues discussed here, EPA has decided to exclude the Dettenbeck experiment from the database of effects to aquatic plants, given the high level of uncertainty in the interpretation of the results. This means removing endpoints 22, 23, 24, and 25 from the COSM database. Our charge question to the panel for the Dettenbeck study is to have the panel comment on EPA's decision to exclude the Dettenbeck study from the COSM database of effects of atrazine on aquatic plants. And I'll take any questions.
Wonderful. Thank you, Dr. Ferrugia. Questions for clarification from the panel?
I don't see any hands up.
Well, there are just 1,000 ways to do a scientific study, aren't there? And you've probably got one of each of those in your various databases.
That is absolutely true. Yeah.
Okay. No questions from the panel?
No, no hands.
All right. So I've got a couple minutes after noon. How about if we reconvene at 1 Eastern? Dr. Ferrugia can have a relaxed lunch now, and we'll convene again in about, what, 57 or 58 minutes?
Yep.
And go for the afternoon.
All right. That's great. Lunch
Thank you
break.
all.
Thank you.
Nice job, EPA folks.
Yep.
There we go.
Yeah, we're coming on now.
Okay.
Yeah. So let's see, I have to go to page 2. I think we're here. Let's see if we can get quorum.
Even if we have, 85% of us, these people made an effort. I'm ready to start and honor that attempt at punctuality.
And we need to do the
All right.
roll call. We get,
Do we need to?
yeah, I'll have that, and then we can proceed with the technical presentations. I'm calling roll call. Let's see, we have Dr. Chapin. Present?
Here.
Dr. Baracall.
Present.
Dr. Jean Harry.
Present.
Dr. Murphy.
Present.
Dr. Sabo Atwood.
Present.
Dr. Trung. Dr. Trung. I see you on mute. Okay, she's
here.
Dr. Chen.
Here.
Dr. Felsot.
Here.
There you are. I see you. Dr. Farrell.
Yes, ma'am.
Okay, there you are. Okay. Dr. Getzinger.
I'm here. Are the other members in the penalty box?
No. No. Dr. Hager?
Present.
Okay. Dr. Mattson?
Here.
Dr. Marlborough? Dr. Marlborough?
I'm here.
Okay, great. Dr. Schmidt? Yes, okay,
I'm here.
thank you. And Dr. Sibley? Dr. Sibley?
Okay, he's in the penalty box.
He's coming from a time zone, so a different.
Yep, that's fine.
zone, so we'll have him back shortly, but we have quorum.
Okay,
Okay.
let's do some rock and roll here. All right, so I'd like to thank our EPA colleagues for leading us clearly through the long and complicated history of the interactions between the EPA and atrazine, and doing a good job of bringing us up to the present. That was the more impressive the more I thought about it. And just to prove that there's no rest for the wicked, Dr. Cold Snow is back in the spotlight talking about the Kaczynski study.
Great, thank you. Let me get it up and going. Okay, so good afternoon. For those not in attendance of my last presentation in the morning, my name is Kayla Cold Snow, and I'm a biologist in EPED. This presentation is a high-level overview of EPA's review of the Kaczynski study group, which represents 2 open literature publications under consideration that describes the effects of atrazine exposure to aquatic plant communities. A more in-depth discussion is provided in the white paper. This presentation will follow the same outline of the previous presentations, including the overview of the study, major concerns and criticisms, and EPA's 2023 reevaluation. So first, I'm going to provide a brief overview of the Kaczynski group and what publications went into the reevaluation. Kaczynski 1984 was one of the 11 publications flagged by the 2012 SAP. For the 2023 reevaluation of this group includes 2 publications, Kaczynski 1984 and Kaczynski and Merkel 1984. These publications present different aspects of the same 2 experiments conducted in the 1980s at Texas A&M University, which were identical except the 1981 experiment was inoculated with water from a spring, while the 1982 experiment was inoculated with water from a river. Kaczynski 1984 presents periphyte and community structure results from these 2 experiments, while Kaczynski and Merkel 1984 just presents the algal community productivity results from both experiments. So now I'm going to go over how the Kaczynski experiments were completed. So the experiments were conducted in outdoor recirculating stream cosms. To create the communities within the cosms were inoculated with water from either Minter Spring in 1981 or Little Brazos River in 1982. For much of this talk, these will be abbreviated as MS and LB. Minter Spring was a concrete standpipe in a pasture. It was almost anoxic, had a temperature of 21 degrees Celsius, and was highly mineralized. Cyanobacteria, diatoms, protozoans, rotifers, and ostracods, and then chironomids were present. Little Brazos River, on the other hand, was located in an intensely farmed region with atrazine use. Dissolved oxygen, or DO, was 75 to 150%. It was more nutrient-rich and mineralized than MS, and green algae, diatoms, invertebrates, and fish were present. In addition to the initial water and inoculates added at the beginning of the experiment, water was added automatically throughout the experiment to account for evaporation, and then twice a week to add new algae and nutrients. The experiments used commercial-grade atrazine, which was 76% active ingredient. So as stated in the previous slide, the difference between the 2 different experiments conducted in 1981 and 1982 was the communities that came from the inoculations. This was the only difference. In year And each year, those two communities received a repeat dose treatment, which was termed the chronic treatment in the publications and will be used throughout this presentation. The treatments were either a control or 0 micrograms per liter or a maintained treatment of 10 micrograms per liter of atrazine. The 10 micrograms per liter was maintained with repeated twice weekly dosings of atrazine. Each of these treatments was replicated 16 times. This treatment lasted for 3 to 4 weeks and was called the colonization period. After 3 to 4 weeks, a single dose treatment termed the acute treatment here and in the publications began. This was considered day 0 of the experiment. With this treatment, the communities previously exposed to chronic treatment received a single higher dose of atrazine. The 4 concentrations in this treatment were a control or 0 micrograms per liter and a single dose of 100, 1,000, or 10,000 micrograms per liter. So here, the 16 cosms from the previous chronic treatment were split into 4 groups of 4. So that, for example, the 16 previous 10 micrograms per liter chronic cosms were separated into 4 0 micrograms per liter, 4 100 micrograms per liter, 4 1,000 micrograms per liter, and 4 10,000 micrograms per liter treatments. The cosms were then observed for 3 weeks with no further dosing. Cosms were sampled throughout both the chronic and the acute treatments, and it's important to note that the terms chronic and acute only refer to the dosing, repeat or single, and they do not refer to the observations made or the results observed, which will be discussed later. So as mentioned earlier, algal community structure and productivity were assessed. To assess structure, slides were sampled 2 and 1 week before the acute treatments, so during the chronic treatments, the day of the acute treatments, so day 0, and then 1, 2, and 3 weeks after the acute treatments. The samples were assessed using a microscope, but the units counted varied with growth form. So for example, individuals versus colonies. This allowed the authors to determine species composition and biovolumes, or the organism's counts per volume of liquid. It's important to note that for the MS experiment, accidents occurred, which resulted in missing data for weeks 1 and 3, and necessitated combining treatments, including some with the control. And lastly, the authors report performing statistical analyses on the data. For productivity, the open water oxygen method was used. With this, dissolved oxygen was sampled 1 week and 1 day before the acute treatments, so during the chronic treatments, the day of the acute treatment, so day 0, and then 2 days and 1, 2, and 3 weeks after the acute treatment. With this data, the authors estimated net community productivity, NCP, respiration, R, and gross primary production, GPP. The authors state that in some cases, especially during extreme suppression of productivity by herbicides, respiration in the light exceeded dark respiration, making computed GPP negative. So they called the corrected values apparent GPP or AGPP. And again, the authors reported performing statistical analyses on the data. The authors also mentioned that atrazine concentrations were sampled. However, it was only the 0 and 10,000 microgram per liter treatments, and only on days 0, 1, 3, and 7 after the acute application. So now that I've given an overview of this group, I'm going to go through how the EPA used this experiment most recently in the 2016 Refined Ecological Risk Assessment. To discuss the COSM database in 2016, I'm going to show the figure I showed earlier when discussing the experimental treatments. As a reminder, the experiment included a repeat dose treatment, which we term chronic treatment, followed by a single dose treatment, which was termed the acute treatment. Endpoint number 28 represented the 10 microgram per liter chronic treatment from both experiments, and the results from those experiments were combined to classify the endpoint as an effect. While endpoint number 44 represented the 100 microgram per liter acute treatment from both experiments, and the MS and LB results were combined as well as the prior chronic treatments to classify the single endpoint as an effect. EPA made the decision to combine the MS and LB experiments into a single endpoint. However, the combining of the prior chronic treatments when assessing the acute treatment was a necessity because the authors present the acute treatment results by aggregating prior chronic treatments, which I'll show in the reevaluation section soon. In previous years, EPA also included endpoints for the 1,000 and 10,000 microgram per liter treatments. However, those were removed after the 2012 SAP because of a new concentration limit of 500 micrograms per liter set by the EPA. These endpoints will not be discussed much more in this presentation. So the way EPA used the Kaczynski group brought about concerns and criticisms, which I'm going to discuss next. First, it's important to note that the concerns and criticisms were conflicting at times, with some critical of the experiments while others supportive if changes were made to the endpoints. So for the 2009 SAP, public comments questioned the effect no effect call for endpoint number 44, or 100 micrograms per liter, and said that an increase in AGPP or apparent gross primary productivity suggests an improvement rather than an adverse effect. The conclusion was that a Brock score of 4 grossly overestimates the impacts, which, as a reminder, Brock scores went from 1 no effect to 5 significant effect without recovery after 56 days. A 4 was a significant effect without return to control levels during an observation period of less than 56 days. The EPA or the SAP said in their minutes that this study should be reevaluated because the algal sensitivity and atrazine half-life simply do not fit with the tremendous amount of information in the literature. For the 2012 SAP, public comments identified 2 main issues. Number 1 was the endpoint should be split from 2 endpoints to 4 to represent the 2 experiments, MS and LB. The reason for this was the experiments used water and algae from 2 sites in different years with different results and should be reported separately. Issue number 2 was that the effect no effect conclusions should be adjusted so that only the 10 microgram per liter LB endpoint out of the now 4 endpoints is in effect. However, the comments did conclude that the effects on paraphyte and productivity at 10 micrograms per liter in the Little Brazo River experiment represents the lowest reliable, though conservatively interpreted, effect concentration in the atrazine COSM database at that time. In the minutes, the SAP said, although some streams were colonized, pre-treated 10 micrograms per liter, there are insufficient data to assign effects at this level, and went on to say that the abstract states succinctly there was little evidence that exposure to 10 micrograms per liter herbicide during the colonization modified the response of algae to any of the herbicides. It's important to note here that the abstract discusses how the colonization during the chronic treatment influenced the acute treatment response, so an interaction, not on solely the chronic treatment response. The panel also noted that Kaczynski was one of the publications discussed by the 2009 SAP as having flawed methodology, which affected interpretation of the results. In the 2016 refined ecological risk assessment, EPA reevaluated the Kaczynski group and concluded that results from both the 10 micrograms per liter and 100 micrograms per liter treatment indicated a statistically significant decrease in primary productivity, and the 10 microgram per liter treatment indicated a slight decrease in biovolume. As I mentioned earlier, EPA removed the 1,000 and 10,000 micrograms per liter endpoints because of the new concentration restriction, but EPA ultimately made no other changes to the Kaczynski endpoints. After the release of the risk assessment, and then again in 2022, EPA received comments which reiterated much of what was said in the past, included restated suggestions to split the endpoints and change the effect no effect conclusions. Now I'm going to go on to EPA's 2023 reevaluation. So based on past concerns and criticisms, as well as EPA's reevaluation, EPA identified 2 determinative concerns: the splitting of endpoints, or in this case, the lack thereof, and the effect no effect conclusions. First, I'm going to go over the splitting of endpoints. So as a reminder, EPA's 2016 COSM database included 2 endpoints based on the Kaczynski publications: endpoint number 28, which was for the 10 microgram per liter chronic treatment, and endpoint number 44, which was for the 100 microgram per liter acute treatment. There have been suggestions to add 2 more endpoints to represent each community tested, MS and LB. EPA has decided to add 2 new endpoints to the database because the experiments were completed during different years, involved testing different communities, and the authors found different results. So the 2 endpoints in the 2016 database will go to 4 endpoints to represent the 2 different communities. The 2 endpoints added will be 28A and 44A, which will be for the MS community, while the 2 original endpoints will now represent the LB community. And so next, I'm going to go over the effect no effect conclusion for all of the endpoints. So before diving into the results, I'm going to go over a few important notes. First, we only considered the chronic repeat dose results that occurred while the chronic treatment was taking place. So the negative week and the negative day samples that you'll soon see in the results. We only considered the acute single dose results that occurred after the acute treatment was applied. So the positive day and the positive week samples that you'll soon see. This is because those treatments were not occurring during the time of the other treatments. For the results presentation, the treatments were likely aggregated, so that all the acute treatments were combined when assessing the chronic treatment results, which was not an issue because at that point, the acute treatments had not taken place. But more importantly, all the chronic treatments were combined when assessing the acute treatment results, which would have been after the chronic treatments took place. There was minimal information, if any, on pH, respiration, and net community productivity, so they will not be presented here. The productivity in the artificial streams was low, and there was significant variation within the treatments. And then finally, as I mentioned earlier, there were areas that necessitated combining treatments and resulted in missing endpoints or missing time points, which I'll point out when we discuss the results next. So first, I'm going to present endpoint number 28A, which now represents the 1981 MS Community 10 micrograms per liter chronic treatment. In Kaczynski and Merkel 1984, the productivity results are presented, specifically AGBP, which as a reminder is apparent gross primary productivity. The control 0 micrograms per liter treatment is the top number in each row, while the 10 micrograms per liter treatment is the bottom number. I'm going to cover the results that occurred after the chronic treatment ended and the acute treatment began. It's important to remember that -1 week and -1 day are during the chronic treatment. We see that there are no statistically significant chronic treatment effects, which will be denoted by an asterisk. Next, in Kaczynski 1984, the structure results are presented, specifically biovolumes. The biovolume values are presented in the top portion, while the multivariate results for those values are presented in the bottom portion. And I'm going to cover the acute treatment and then interaction so we can look at only the chronic treatment. We see that the multivariate chronic treatment result is statistically insignificant, which means we did not look at the individual treatments above. Therefore, there were no statistically significant chronic treatment effects, but do note that there was a statistically significant effect on streams, which points to that within treatment variability I had mentioned. There were statistically significant chronic treatment effects on species-specific biovolume across the 2 chronic treatment time points. However, the time points did not share any species in common and therefore are considered transient. Based on the 2023 reevaluation, EPA has scored this endpoint as no effect. So next I'll present on endpoint number 28, which now represents the 1982 LB community, 10 micrograms per liter chronic treatment. For the productivity results presented in Kaczynski and Merkel in 1984, we see that there's a statistically significant chronic effect with 2 asterisks, meaning a p less than or equal to 0.01. Specifically at week -1, where the productivity in the 10 microgram per liter treatment was 45% lower, and at day -1, where productivity was 35% lower. Next, for the structure results presented in Kaczynski 1984, we see that the multivariate chronic treatment result is statistically insignificant, which means, again, we do not look at the individual treatments above. Therefore, there were no statistically significant chronic effects, but again, we see that within treatment variability with a statistically significant stream effect. Like the last endpoint, there were statistically significant chronic treatment effects on species-specific biovolumes across the 2 chronic treatment time points. However, the time points did not share any species in common and therefore are considered transient. And so based on the 2023 reevaluation, EPA has scored this endpoint as a fact due to the statistically significant effect on productivity. So now I'm going to move on to the acute endpoints. First, endpoint 44A, which now represents the 1981 MS Community 100 micrograms per liter acute treatment. Again, in Kaczynski and Merkel 1984, the productivity results are presented. And this figure, AGPP, is on the y-axis in grams of oxygen per meter squared, while time is on the x-axis. The different treatments are indicated by the numbers. For the acute treatment time points, we'll only look at the results that occurred after the acute treatment was applied, and only the 0 and 100 micrograms per liter concentrations. We see that the 0 and 100 micrograms per liter acute treatments always overlap, which is denoted by the continuous line. Therefore, there were no statistically significant acute treatment effects. Now the structure results presented in Kaczynski 1984. Here you see the consequences of the MS experiment accidents I mentioned earlier, with week 1 and 3 data missing and the atrazine treatments that were combined, which is indicated by the plus sign. This includes the control with the 100 micrograms per liter, which are the 2 treatments we're interested in here. We will only look at the results that occurred after the acute treatment was applied and only the 0 and 100 micrograms per liter concentrations, which again were combined. We see that the multivariate acute treatment result is statistically insignificant, which means we did not look at the individual treatments above, which we likely could not anyways because of the combining of the treatments. Therefore, there were no statistically significant acute treatment effects. But again, we see that within treatment variability with a statistically significant stream effect. The species-specific biovolumes results were difficult, if not impossible, to interpret for the MS community because the authors combined the treatments. And so based on the 2023 reevaluation, EPA scored this endpoint as no effect. So finally, on to endpoint number 44, which now represents the 1982 LB community 100 micrograms per liter acute treatment. Again, the productivity results are presented in Kaczynski and Merkel 1984. We see that there was a statistically significant acute effect on day 0, no statistically significant acute effect on day 3 or week 1 and 2, and then a statistically significant acute effect on week 3, where the 100 microgram per liter treatment is actually greater than the 0 microgram per liter treatment. EPA has determined that the effects on day 0 was a slight or transient effect because it was no longer present on day 3. The effect at week 3 was not considered, day 3, the effect at week 3 was no longer considered in our in our effect, no effect conclusions due to it being an increase in AGPP. So next, the structure results presented in Kaczynski 1984. We see that the multivariate acute treatment result is statistically significant. However, if we look at the individual treatments above, we see that there is no statistically significant difference between 0 and 100 micrograms per liter treatment, which is denoted by the A's. Therefore, there were no statistically significant acute treatment effects. And again, we see that within treatment variability with a statistically significant stream effect. For this endpoint, the species-specific biovolume results were presented in a way that made it impossible to tell exactly which acute treatment was different from the control. And so based on the 2023 reevaluation, EPA scored this endpoint as no effect, given the slight transient nature of the effect on day 0. So finally, I'm going to present EPA's 2023 conclusions. Here's the figure I presented earlier. As a reminder, in 2016, we had 2 endpoints for the Kaczynski group, both of which were scored as an effect. Endpoint number 29 and number 30 were removed in 2016 because of the concentration limit set. And then after the 2023 reevaluation, these 2 endpoints will become species-specific to represent the LB community. 2 new endpoints will be added to represent the MS community. Endpoint number 28 will be scored as no effect. Endpoint number 44A will be scored as no effect. Endpoint number 28 will be scored as effect, which as a reminder was a repeat dose chronic exposure. And endpoint number 44 will be scored as no effect, which as a reminder was a single dose acute exposure despite being a greater concentration than endpoint number 28. So this brings us to charge to the panel for this presentation, which is question number 5, please comment on EPA's 2023 decision to include the Kaczynski study group, add 2 additional endpoints, and update the effect, no effect conclusions for the 4 endpoints. Do you have any questions for clarification?
All right, thank you, Dr. Colsnow. Any questions for clarification from the panel?
Dr. Mattson, Dr. Chapin is Dr. Mattson.
Oh, got it. Okay.
All right, who's first?
You are.
Okay, so I was not confused until you just wrapped up there. Were the chronic treatments started before the acute treatments were started? So they were started before the -1 week?
Yes, that's correct. Well, no, they were started during what is considered the -1 week of the results. So day 0 is the start of the acute treatment. And then prior to that is when the chronic treatment was happening. The chronic treatment was considered a colonization period, and they defined day 0 as the start of the acute treatment.
Okay, so for the Brazos water, you have an effect, then you have no effect for week 0 and 3 days after, and then you have an effect for 1, 2, and 3 weeks after. Am I reading that right?
Yeah, so during -1 week, which is during the chronic treatment, there was an effect. During -1 day, which again is during the chronic treatment, there was an effect. And then later on, you have effects at week +1, +2, and +3 weeks. That's happening during the acute treatment.
Thank you.
Again,
No.
at least 1,000 different ways to do science.
No other hands raised at this time.
All right. Thank you, Dr. Cold Snow. All right, Dr. Lowett, you're back in the spotlight. Talk about Segwin. Seguin?
Okay.
I hope he's not, there we go.
Yes.
Sorry, I was just trying to get my slides up.
Okay.
Okay. Good afternoon. For those of you not in attendance this morning, I am Michael Lowett and a biologist in EFED. My presentation is a high-level overview of EPA's review of the Segwin 2001 study group, which represents 2 of the open literature publications under consideration that describe effects of atrazine exposure to aquatic plants. A more in-depth discussion is provided in the white paper. This presentation will follow the same outline of the previous presentations, including a brief overview of the study group, major criticisms and concerns, and EPA's current position on the study group after the 2023 review. Now I will move to the overview. As mentioned, there are 2 publications by Segwin published in 2001, and both were flagged by the 2012 atrazine SAP as warranting further review and consideration. These publications describe results from an experiment in outdoor freshwater mesocosms, one presenting the response of periphyton exposed to atrazine, and the other the response of phytoplankton to atrazine. In the past, EPA treated the results from these publications separately. The 2 publications are considered together for the reevaluation because public comments that asserted that the publications likely describe different results from the same experiment, specifically the response of the periphyton and phytoplankton communities contained within the same experimental units, or put another way, within the same mesocosms. Next, I'll provide a high-level overview of the experimental design. The Segwin 2001 experiments were conducted in large outdoor above-ground tanks. The tanks were filled with sediment and water from a local pond, although tap water was added as well. The pond was the source of the periphyton, phytoplankton, and zooplankton community. In the case of periphyton, glass slides were submerged in the tanks and were colonized during an acclimation period prior to atrazine dosing. Those slides were maintained in the cosms during the exposure period and were used as the source for sampling the periphyton. 2 nominal atrazine concentrations were tested, and an acetonitrile control was included. All groups had 3 replicate mesocosm tanks. This slide illustrates that one control, represented by the 0 micrograms per liter on day 0, and 2 different concentrations of atrazine were tested, represented by the nominal 2 and 30 microgram per liter dosing on day 0, with 3 replicates each, represented by the number 3 in parentheses. It is not shown on this slide, but the experiments included concurrent side-by-side experiments with another pesticide, 2 and 30 micrograms per liter of nicosulfuron, which shared the same control mesocosms as the atrazine treatments. I'll be coming back to this later. The authors measured several biotic variables associated with the aquatic plant community. Taxonomic identification of periphyton and phytoplankton was used for different purposes. For example, the Bray-Curtis indices, a community dissimilarity index, was calculated for phytoplankton based on taxonomic data. Photosynthetic rate was measured as well, but excluded from consideration of the database due to a lack of replication, which was one of the EPA criteria for acceptance and review. Now I'll present EPA's use of the Seguin 2001 publications as of 2016. The original EPA review of the two Seguin 2001 publications considered them of sufficient quality relative to the criteria for acceptance and review and the evaluation criteria to be included in the database of effects to aquatic plants. Prior to the 2023 reevaluation, the two publications were treated separately for database purposes, and therefore two endpoints, or in other words, test concentrations, were extracted from each publication. In other words, each test concentration had a separate endpoint for periphyton and phytoplankton, as shown in this illustration. EPA previously concluded that there were no effects on periphyton at either tested concentration, shown on the left, but that there were effects on phytoplankton at the same two test concentrations, shown on the right. Next, I'll present major concerns and criticisms of the Seguin 2001 publications. There are four main themes to major criticisms and concerns associated with the Seguin 2001 publications. One is if the endpoint from the two publications should be combined. Two, question EPA's effect, no effect conclusions. And one is about the use of acetonitrile as a solvent. First comment is about if the two publications are describing the same or wholly independent experiments. A public commenter has consistently asserted that different aspects of the same experiment are described in the two publications. The importance, as they point out, is that the EPA approach to the aquatic plant effect database of COSM studies has been to have a single endpoint per test concentration in each experiment. That is, there should be no splitting of different responses of the community. For example, different measures of community structure, such as diversity or compositional similarity, would not receive independent endpoints. And there should be no splitting of different parts of the community. For example, the response of periphyton and phytoplankton would not receive independent endpoints if they were part of the same assemblage of plants within a COSM. The second main concern is about the effect, no effect conclusion at 30 micrograms of atrazine per liter. As a reminder, at the time of these comments, EPA considered there to be no effect on the periphyton and an effect on the phytoplankton. Comments received on these conclusions were contradictory. One public comment proposed that the no effect call on periphyton be changed to an effect based on a stimulatory response of chlorophyll A. One of the SAP comments apparently mischaracterized the EPA conclusion and recommended changing the periphyton response from effect to no effect. Another SAP comment is seemingly in agreement with EPA's effect, no effect conclusions for periphyton and phytoplankton, but appears to have mixed up the two publications by referencing the phytoplankton publication. The third main concern is about the effect, no effect conclusion at 2 micrograms atrazine per liter. As a reminder, at the time of these comments, EPA considered there to be no effect on the periphyton and an effect on the phytoplankton. The public comment about periphyton is the same as mentioned on the last slide, which proposed that the no effect conclusion on periphyton be changed to an effect based on a stimulatory response of chlorophyll A. For phytoplankton, the public commenters have contended that the observed response was not clearly an effect, in part because it appeared slight or transient, suggesting that EPA's conclusion be changed from effect to no effect. Finally, the final main concern was about the use of acetonitrile as a solvent. The 2012 SAP did not provide any recommendations, specific criticism, or suggest that acetonitrile would be a cause to exclude the study group from the database, but pointed out that acetonitrile was used as a solvent, but that the amount added was not listed, and rarely is this solvent used in ecotoxicological dosing. Now let's focus on EPA's 2023 reevaluation. This slide reiterates the 4 determinative concerns previously mentioned. I'll now go through each one at a time. The COSM database is intended to have a single endpoint per test concentration. That is, there would not be a separate endpoint to represent different parts for the aquatic plant community, such as periphyton and phytoplankton. There were previously 4 endpoints extracted from the 2 Seguin 2001 publications representing 2 test concentrations. 2 represented the response of periphyton and 2 the response of phytoplankton. This is because EPA previously treated the periphyton and phytoplankton results as coming from separate experiments. The 2 Seguin 2001 publications do not cite one another. However, the 2 publications report identical and precise water quality conditions in the mesocosms. If the experiments were independent, then it would be highly unlikely that the water quality conditions would be identical, given the precision of the reported values and because the source water and sediment were from a pond. Despite some minor differences in wording and descriptions, the basic description of the experimental setup is also identical. For example, experimental location, mesocosm construction, replication, test concentrations, testing of both atrazine and nicosulfuron, and test duration. Therefore, EPA has decided that the 2 Seguin 2001 publications should be represented by a single endpoint for each test concentration in the database. This figure illustrates the 4 previous endpoints for the 2 Seguin 2001 publications and the 2 endpoints after considering the results of the 2 publications as coming from the same experiment. In other words, the periphyton and phytoplankton results are from the same mesocosms. Endpoint designators, for example, number 83, were maintained for dataset integrity, but they now represent both publications. The old designators for Seguin 2001B, for example, number 85, were retired from the database. Now I will discuss the remaining concerns under the context of the 2 publications being considered as describing the same experiment, keeping in mind that the original comments were made within the context of considering them as separate experiments. As a reminder, EPA's no effect conclusions in 2016 were no effect on periphyton and effect on phytoplankton. There was a statistically significant effect on periphyton chlorophyll A, but it was a no effect conclusion because the response was stimulatory. In other words, an increase in chlorophyll A. And although it might be useful information for characterization purposes, EPA does not consider stimulatory effects on biomass to be adverse to a tested taxonomic group. On the other hand, stimulatory or inhibitory shifts of parts of a community could be considered adverse within the context of community structure. Although the stimulatory effects on periphyton were originally considered in isolation of the rest of the plant community, that is the phytoplankton, shifts in community structure, such as the periphyton versus the phytoplankton, would be considered potentially adverse effects, assuming that there are comparable data. If we compare the chlorophyll A data of the periphyton and the phytoplankton exposed to 30 micrograms atrazine per liter over the study time course, then it does appear that the periphyton increased relative to the controls at the end of the experiment, whereas phytoplankton did not. This is shown in these figures with chlorophyll on the y-axis and date on the x-axis, which is presented as calendar date in the periphyton plot and the number of days post-exposure on the phytoplankton plot. The final sampling was day 40 in both cases. A red A represents 30 micrograms atrazine per liter, and the red C represents the control. This comparison suggests a treatment-related shift in the structure of the overall plant community, but it might have limited meaning since the periphyton were reportedly dominated by a single species. Nonetheless, an effect has already been established on phytoplankton at 30 micrograms per liter for a change in community composition as measured by the Bray-Curtis indices. I don't present that data since public comments on the SAP have not expressed concern about that conclusion, and the 2012 SAP concurred with that conclusion. Therefore, with the combining of the publications, there is an effect at 30 micrograms per liter based on a change in the composition of the phytoplankton, which is independent of the interpretation of the meaning behind the stimulation of chlorophyll A and periphyton in the context of the larger plant community and the ecological relevance of a periphyton community dominated by a single species. This figure illustrates the two previous 30 micrograms per liter endpoints for SEGWIN 2001 publications and the one endpoint after considering the results of the two publications together. The effect is based on a shift in the community structure of the phytoplankton community and potentially the broader plant community. The comment on periphyte is the same one mentioned earlier regarding the 30 microgram per liter treatment group. That is, EPA considering there to have been an effect and the 2012 SAP panel considering there to have been no effect. However, the comment appears to be a misinterpretation. In this case, EPA noted that there was a slight increase of chlorophyll A, but it was not statistically significant and was considered a no effect on those grounds. In terms of phytoplankton, EPA's 2016 COSM database considered there to be an effect solely based on the increased abundance of a single taxonomic group, that is the Chrysophyceae, relative to the others at study termination. As related to what I discussed a moment ago, the important distinction here is that the stimulatory effect was on one part of a community within the context of the rest of the community, representing a shift in community structure. At the time of the writing of the white paper, EPA was not aware of a specific rebuttal to the Chrysophyceae response as being treatment related. Although there were previous critiques about the effect conclusion, they apparently misinterpreted or misunderstood what EPA based the effect on. So those are not addressed here because those comments did not contradict EPA's reasoning and were based on responses observed in other variables. Finally, EPA has considered potential effects observed only at study termination to be potentially treatment related, with the acknowledgement and caveat that had the study been extended, that effect may have been revealed to be transient. So EPA took a closer look at other lines of evidence to determine in a weighted evidence approach the likelihood that the increased abundance of Chrysophyceae may have been transient or slight, in other words, not a clear effect, was potentially treatment related, or if there was no additional information either way. This approach was taken because the magnitude of effect is unknown and the lack of additional time points precludes a direct determination of whether the increased abundance was transient. First, it's notable that the increase in Chrysophyceae density appears only on day 40, circled in red on the table, and that it occurs in all treatment groups, that is the 2 and 30 microgram per liter treatments for both atrazine and nicosulfuron, which would be highly coincidental to have occurred simultaneously and independently after 40 days exposure to two chemicals with different modes of action. Just to note, EPA previously and continues to consider the decreased Chlorophyceae abundance seen on day 17 in the 2 micrograms atrazine per liter treatment shown in the table to have been transient because it only occurred on a single time point during the middle of the experiment. This slide shows that there were successional shifts that occurred throughout the experiment, which can complicate the ability to discern treatment-related effects. In particular, the sudden increase in Chrysophyceae abundance on day 40. The figure presents the relative percentage of different taxonomic classes on the y-axis and time on the x-axis. Although this figure potentially represents control data, unfortunately, the study authors did not explicitly state what is presented. In other words, the controls only or all the experimental tanks. Nonetheless, the text importantly states that there was a species succession during the experiment in all tanks, and that the succession in all the tanks was similar to that of the controls, with some differences in time lags and proportions. The takeaway here is that the sudden shift in Chrysophyceae across controls and treatments makes it very difficult to ascertain treatment-related effects within a single time point. Finally, although there was a statistically significant increase in Chrysophyceae abundance, there was not a corresponding statistically significant difference in the Bray-Curtis index, which is a measure of community similarity or dissimilarity, on day 40 between any of the atrazine or nicosulfuron treatment groups and the control, indicating that the magnitude of the change in Chrysophyceae abundance couldn't be detected, at least in the context of the entire community. This figure shows similarity of the treatment groups relative to the control on the y-axis and time on the x-axis. The asterisk indicates when those differences are statistically significant. It's important to note that a lack of correspondence between the two measures does not discount the potential effect on the community structure represented by either measure alone. Rather, that in this case, there is not a change in the Bray-Curtis index that would provide another line of evidence of a potential treatment-related effect on chrysophyceae. This figure illustrates the two previous 2 microgram per liter endpoints for the Seguin 2001 publications and the one endpoint after considering the results of the two publications together. The no effect conclusion is based on a lack of effects of periphyton, as previously concluded, and a change from an effect to no effect on phytoplankton based on the reevaluation. For phytoplankton, based on the totality of the lines of evidence, EPA considers that the author-reported successional dynamics occurring during the experiment, combined with similar responses in nicosulfuron, the lack of magnitude of effect data, and the lack of additional time points to judge the difference between the atrazine treatments and controls, collectively raise enough uncertainty to question if increased chrysophyceae abundance on day 40 was an effect due to atrazine exposure or possibly just represents a transient or false response due to a factor such as a lag in taxonomic succession among the tanks. And finally, as mentioned, the 2012 SAP panel pointed out that acetonitrile was used as a solvent. It's rarely used in ecotoxicological testing, and that the amount used was not reported. This comment was specific to the Seguin 2001B publication because the Seguin 2001A publication was silent on how atrazine was dissolved. However, this discussion applies to both publications because EPA considers that the results from both publications to be from the same experiment. Of foremost importance to these concerns is that a solvent control was included in the experiment. Therefore, assuming conservation of any impact of the solvent among the mesocosms, differences between the treatment groups and controls can be reasonably considered to reflect potential treatment-related effects. This contrasts importantly with the Lampert study group, which also did not report the concentration of solvent used, but in that case, there was no indication that anything other than a negative control was used for comparison, and there was evidence that the solvent may have interfered with the interpretation of the study results. Although acetonitrile is not a standard solvent used in ecotoxicity testing, EPA did not place restrictions on solvent type, and available data indicate low toxicity to algae. Finally, although the concentration was not provided, estimates based on reported solubility of atrazine in acetonitrile suggest that it is possibly lower than the reported toxicity of acetonitrile to algae and EPA's study acceptance criterion. Although acetonitrile is not a standard solvent used in ecotoxicity testing and the concentration used was not reported, EPA considers it reasonable to retain the results from the Seguin 2001 study group in the COSM database based on what is known about acetonitrile and the use of a solvent control in the experimental design. Now I will present EPA's 2023 conclusions for the Seguin 2001 study group. This slide summarizes the changes to the COSM database after the 2023 reevaluation. This figure illustrates the 4 previous endpoints for the 2 Seguin 2001 publications and the 2 endpoints after EPA decided to consider the results of the 2 publications as being from a single experiment. Endpoint designators number 83 and number 84 were maintained for dataset integrity, but they now represent both publications. The old endpoint designators for Seguin 2001B, number 85 and 86, were retired from the database. The effect conclusion for 30 micrograms per liter reflects the previous interpretation of an effect on phytoplankton community structure and a potential shift in the overall plant community based on the increased chlorophyll A in the periphyton relative to that of the phytoplankton. The no effect conclusion for 2 micrograms per liter reflects a change in the interpretation of the phytoplankton response. In other words, changing from an effect on chrysophyceae based on increased abundance relative to other taxonomic groups to a no effect, given the considerable uncertainty of this being treatment related and more than a transient or slight effect. Finally, the charge to the panel for question number 6 to please comment on EPA's decision to include the 2001 Seguin study group and update the no effect conclusions for the 2 included endpoints. Thank you for your attention. Are there any clarifying questions on the Seguin 2001 study group?
All right. Thank you, Dr. Lowett. Clarifying questions from the panel? Dr. Felsot.
Yeah, for my video here. Whoops, sorry. Yeah, I had to move to my office because I have to teach soon. In figure 1 of Seguin 2001B, I think it's for the control, it shows at different times that the experiments were set up, there's big shifts in the taxa. How does EPA consider this natural shift relative to the shifts that you see when you add atrazine? In other words, everything's changing naturally without the atrazine. It changes with atrazine. So can you really say there's an effect if everything is changing naturally, I guess is what I'm asking?
So the key is to be able to, if we can have confidence that we can discern when the change in due to atrazine is greater than any successional shifts that might be occurring. And in this case, for instance, we did feel that based on the data they provided and the statements they made on the successional dynamics in this study, that relying on a change at any individual time point was going to be hard, because they acknowledged that there were lags in the successional dynamics at any given time point. But if you see those changes over longer time points, then we do have more confidence that it's going to be due to atrazine exposure rather than just successional dynamics.
Okay, thank you.
All right, Dr. Schmidt.
Hi, yeah, thanks for that great summary. My question is similar. It seems that the difference between the control and day 40 would, to some degree, embrace the differences in lag times and successional patterns, right? So the day 40 observation is different from those natural patterns observed in the control. So it seems to me that maybe there's more emphasis in this conclusion on the fact that there's not sequential observations of that difference, and it's only perhaps a transient observation on day 40.
Correct. That's exactly what we're saying. So just to create a theoretical, had the change been consistent over multiple sequential time points, then we would have greater confidence that that successional shift would become less important in the response, and that we would be, seeing an actual response due to atrazine. But in this case, we only have a single time point, and then of course the other factors like it not showing up till day 40 and showing up in nicosulfuron as well, that really raised doubt as to whether or not that's atrazine related versus just, that real-time lag in the successional shift, which the authors acknowledged.
Okay.
Thank you.
I see no other hands up. So I guess we'll move along, and Dr. Lowett has the last at bat with another Seguin review.
Okay, give me a second. Okay. Good afternoon. For those of you not in attendance this past presentation, I'm Michael Lowett, and a biologist in EFED. My presentation is a high-level overview of EPA's review of the Seguin 2002 publication, which represents one of the open literature publications under consideration that describe effects of atrazine exposure to aquatic plants. A more in-depth discussion is provided in the white paper. This presentation will follow the same outline of the previous presentations, including a brief overview of the study, major criticisms and concerns, and EPA's current position on the study after the 2023 reevaluation. Now I'll move on to the overview. Seguin 2002 was another publication flagged by the 2012 atrazine SAP as warranting further review and consideration. It describes a freshwater outdoor mesocosm experiment that is like that described in the two Seguin 2001 publications, but it only focuses on the phytoplankton community. The 2001 publication describing phytoplankton is cited for methodological details, and that will become important later in this presentation. Now I'll provide a high-level overview of experimental design. The Seguin 2002 experiment was conducted in large outdoor above-ground tanks. The tanks were filled with sediment and water from local ponds. Details were not provided, but the phytoplankton reportedly came from a single pond, and the zooplankton were obtained from a combination of several ponds, which is different than the 2001 publications. Source zooplankton were size fractionated before introduction into the mesocosms. An acclimation period of the created mesocosms preceded dosing. A single atrazine concentration was tested, and an acetonitrile control was presumably included. The 2002 Seguin publication cites the 2001 phytoplankton publication, that's 2001B, for additional details and methods, and that publication discusses the use of acetonitrile and the use of an acetonitrile control. 2 replicate mesocosm tanks were used. This slide illustrates that there was 1 control represented by the 0 micrograms per liter on day 0, and 1 treatment group represented by the nominal 30 microgram per liter dosing on day 0, with 2 replicates each represented by the number 2 in parentheses. This study differed from the 2001 experiment in several ways, including the sourcing of zooplankton from multiple and different ponds than the phytoplankton, a shorter observation period, which was 25 days instead of 40, the use of 2 replicates instead of 3, and a single test concentration instead of 2. The authors measured an abiotic and several biotic variables associated with the aquatic plant community. I'll come back to some of these later, but won't be going into details. Taxonomic identification was used to assess abundance of individual classes of phytoplankton, and then taxonomic information was used to calculate community diversity and a community dissimilarity index called Bray-Curtis. The publication was not clear on what level of taxonomic resolution was used for the diversity and Bray-Curtis index. Finally, statistical analysis was not included for all measured variables, but just as a reminder, it was not a pre-screening or acceptance review criterion for study exclusion, and reviewer judgment was permitted for determining potential effects of atrazine exposure from provided data. Now I will present EPA's use of the Seguin 2002 publication as of 2016. The original EPA review of the Seguin 2002 publication considered the study of sufficient quality relative to the criteria for acceptance and review and the evaluation criteria to be included in the database of effects to aquatic plants. There was a single endpoint, in other words, treatment concentration from this study, which was 30 micrograms per liter, and the effect, no effect conclusion was effect for changes related to the phytoplankton community, specifically reduced biomass and dissolved oxygen, and a change in community structure. Next, I'll present major concerns and criticisms of the Seguin 2002 publication. There are 3 main themes to major criticisms and concerns associated with the 2002 publication, none of which disagree with EPA's overall effect, no effect conclusion, or inclusion of the study in the database. 2 deal with the response of biomass, and the 3rd is about the use of acetonitrile as a solvent. The comment associated with the first issue points out that recovery observations were not a feature of this study and that recovery would be expected. The 2012 SAP panel stated that while the results indicate that there was a 30% reduction in algal biomass over a 21-day exposure to 30 micrograms per liter atrazine, recovery was not studied. The preponderance of evidence in the literature indicates that recovery would be expected. EPA agrees that recovery was not a feature of this study. In the comment, the panel refers to the reduction in dry weight based on the percentage reduction cited, but the comment presumably applies to the smaller magnitude reduction in chlorophyll A as well, given that chlorophyll A can also be used as a surrogate for biomass. The second concern is also about biomass. Although the public comment did not question the results, it suggested that the results are apparently contradictory with the experimental results described in the 2001 publication. In 2016, EPA decided that phytoplankton biomass, as represented by chlorophyll A, showed no effect at 30 micrograms per liter in the experiments described in the 2001 publication, but that it did show an effect at 30 micrograms per liter in the experiments described in the 2002 publication. Here, the only direct comparison of biomass is for chlorophyll, because dry weight was only reported in the 2002 publication. Finally, just a reminder, EPA concluded that there was an effect on 30 microgram per liter endpoint for the 2001 segment experiments, but based on community structure, not chlorophyll A. Final concern was discovered by EPA during the reevaluation and is about the potential use of acetonitrile. The 2002 publication cites the 2001B publication for details about the experimental setup, which presumably includes the use of acetonitrile to dissolve atrazine and the use of a solvent control. As mentioned in the presentation on the Seguin 2001 study group, the 2012 SAP pointed out that acetonitrile is rarely used in ecotoxicity testing, and this critique was later reinforced by public comments. Now let's focus on EPA's 2023 reevaluation. This slide just reiterates the three determinative concerns previously mentioned, and I'll now go through each. When we consider the comment about recovery, it's worth reiterating that effects to several variables, that is biomass, dissolved oxygen, and community structure, impacted EPA's effect conclusion for the 30 microgram per liter endpoint. Although hypothetically, there is the potential for recovery from effects of atrazine exposure in any causal experiment, it was not a feature of many studies, nor was it a requirement of inclusion in the COSM database. Specifically, in regard to biomass in this study, represented by chlorophyll A and dry weight, both endpoints became increasingly lower in the treatment group compared to the control over multiple and sequential time points, and represented a monotonic trend over that time period. There were reductions of up to 57% and 68% for chlorophyll A and dry weight, respectively, in the treatment groups compared to the control by the termination of the experiment. Although tests of statistical significance were not performed, potential treatment-related effects are clear based on trends in the data over time, the magnitude of the differences between the treatments and controls, and the amount of variability among replicates. For illustrative purposes, the plot shows the change in chlorophyll A on the y-axis over time on the x-axis for the treatment group and the control group. Data for dry weight are similar, but not shown here for clarity because it was provided in the publication in a table format. Recovery was not reported for any variable measured in this study, except for the apparent recovery of dissolved oxygen on day 12, although the treatment diverged from the control again starting about day 17, and that's in the top plot. Even if biomass had recovered, it could potentially be associated with a change in community structure. For example, a shift in relative abundances of species toward less sensitive ones. In this case, there was a clear shift in community structures evidenced by changes in density of individual taxonomic groups and as represented by the Bray-Curtis index shown here, with the index expressed as the percent similarity between the treatment and control communities on the y-axis over time on the x-axis. Similarity decreased over time, and the treatment was determined to be statistically different from the control by day 9 forward, as indicated by the asterisk. EPA acknowledges that some of the measured variables could have potentially recovered. However, it's also important to note that variables with clear effects followed by recovery are still classified as effects in the COSM database. In this case, EPA does not find direct evidence of recovery in the study, and it's also important to note that several variables were impacted in this experiment, including changes to community structure. Therefore, EPA concludes that there was an effect at 30 micrograms per liter, meaning that the endpoint number 87 remains unchanged after the reevaluation. As discussed above, A public comment pointed out that phytoplankton biomass decreased relative to the controls in the experiments described in the 2002 segment publication, but not in the 2001 publication. Although the commenters do not question the results, they suggest that the results are apparently contradictory. On the surface, these results could seem contradictory, but there was a clear difference in the initial composition of the phytoplankton communities tested in the two experiments. This can be seen by comparison of the initial community composition of the phytoplankton community in the 2001 publication experiment shown on the left, which is dominated by chlorophyceae, and that of the 2002 publication experiment shown on the right, which is dominated by cyanobacteria at the start of the experiment. The y-axis presents the relative proportions of different taxonomic groups presented as a percentage in one case and a density value in the other. The x-axis shows how the communities changed over the experiments. Given the clear difference in the initial communities, there's no reason to expect the exact same response in biomass after exposure. Therefore, EPA does not consider the results contradictory or that there is an impact on study interpretation. And finally, as mentioned, the 2012 SAP panel pointed out that the Seguin 2001B publication reported that acetonitrile is used as a solvent, and they commented that it is rarely used in ecotoxicological testing and that the amount used was not reported. However, EPA has determined that the comment likely applies to the Seguin 2002 publication as well, because it cites Seguin 2001B for details about experimental setup and design. Of foremost importance to the concerns expressed is that Seguin 2001B reports that a solvent control was included. Therefore, assuming conservation of any impact of the solvent among the cosms, differences between the treatment groups and controls can be reasonably considered to reflect potential treatment-related effects. Again, this contrasts with the Lampert study group, which also did not report the concentration of solvent used. But in that case, there was no indication that anything other than a negative control was used for comparison, and there was evidence that the solvent may have interfered with the interpretation of the study results. Although acetonitrile is not a standard solvent used in ecotoxicity testing, EPA did not place restrictions on solvent type, and available data indicate low toxicity to algae. Finally, although the concentration was not provided, estimates based on reported solubility of atrazine and acetonitrile suggest that it was possibly lower than the reported toxicity of acetonitrile to algae and EPA's study acceptance criterion. Although acetonitrile is not a standard solvent used in ecotoxicity testing and the concentration used was not reported, EPA considers it reasonable to retain the results from this study in the COSM database based on what is known about acetonitrile and the use of a solvent control in the experimental design. Now I'll present EPA's 2023 conclusions for the Seguin 2002 publication. EPA decided that its previous review of the Seguin 2002 publication was sufficient and that endpoint 87 remains in effect to phytoplankton based on reductions in chlorophyll A, dry weight, dissolved oxygen, and a change in community structure. Finally, the charge to the panel is to comment on EPA's decision to include the 2002 segment study and make no changes to the no effect conclusion from the single endpoint, included endpoint. Thank you for your attention. Are there any clarifying questions on this study?
Okay, questions for clarification for Dr. Lowett? Dr. Barakal.
Yes, it's not necessarily referred to this study. It's something you said that made me wonder. You mentioned that something about the use of statistical methods was not a requirement for being included in the COSMO database. Can we be provided what is the criteria that would make a study be included in the COSMO database or not? Is that listed in the white paper? I couldn't remember.
I believe, but we'll have to double check that was included in the docket. And that document is the original COSM evaluation. I don't remember what the file name is, but we can get that to you. It should be in the docket, and if it's not, we can make sure you get it.
Okay,
yeah, and you can send it directly to me, to Tamu Gibson.
Sorry, this is Frank Ferrugia. I wanted to add one thing. So those criteria, just to refresh everyone, that those criteria and the specific reasoning behind them are not subject of this SAP. So while they're provided for context within these 11 studies. So, yeah.
Yes.
Yeah,
Okay.
good.
Yep.
Dr. Felsot?
Yeah, so you just, in a couple of previous slides, you showed figure 3 from Seguin 2002, and it's clear that cyanobacteria are dominating and driving the Bray index, I think. So the control similarly has acetonitrile only, and then the treatment adding atrazine. It's remarkable in that graph how in the atrazine treatment, the cyanobacteria don't seem to be changing their, let's see, it's the density, but it's really changing a lot in the control. Have you considered that acetonitrile might be an interesting nutrient metabolite for cyanobacteria?
No, this is Frank Ferrugia again. No, we haven't considered that. We haven't run across any data that would suggest that that would be the case, that blue-green algae would use acetonitrile as a food source, essentially. So if the panel does have information about that and regarding the acetonitrile, we'd certainly be interested in knowing that condition. So we did do a lit search to try and find some more information about it.
Right.
Got very limited information about toxicity responses of algal communities to acetonitrile.
So I have another question, and it relates to this data on cyanobacteria, but I just want to know, it's really a qualitative question. If you say the effect is 1, so you're assuming that some kind of change, which also implies that there's an adverse effect. Yet we have a lot of problems with cyanotoxins from cyanobacteria. So it's not clear to me why knocking down cyanobacteria. I'm assuming these are disturbed systems, since agriculture is a disturbed system. It's not clear to me why that would be considered an adverse effect. Do you want to comment on that?
So we're not making distinctions on which community members might increase or decrease in the community structure on whether or not that's an adverse effect or not. We're simply considering any change in community structure, regardless of which species are changing, to be a potentially adverse effect, because ultimately the function and resiliency of the community could change. Now, that does acknowledge what I think you're getting at, that maybe some species increasing could have a negative impact themselves on an ecosystem. But we're not making that kind of distinction in these calls.
Yeah. Okay. So really, the endpoint is change. Don't assign any other qualitative terms to change, basically.
Yes.
Okay. Thank you.
Okay. I don't see any other hands up. So
Neither do I.
if nobody else has any questions,
Okay.
we're due for a break, and then we're going to come back for some public comments. So I've got 2:16. Why don't we round it down to 2:30 Eastern time? We'll reconvene in 14 minutes.
Yep.
Right here.
Yep.
Thank you.
Okay.
Thank you very much, EPA colleagues. Nice presentations.
Yep. Correct.
Anybody hear me?
I am. I apologize. I was on another call, so it's very busy.
Oh goodness, you're not running you're not running another meeting on
Yes,
us,
I
are you?
did. On another issue, another topic, scientific
Oh
topic.
man.
Yeah.
All right. So it's go time.
Dr.
Do we
Marlborough has he has a check.
I'm just saying I'm here.
Oh, okay, great. Thank you.
do we need to call the roll again?
No, we do not. We just
Okay.
doing a quick break.
All
Yep.
right. Let's hit a button. Okay. Thank you to our EPA colleagues for your presentations today. Let's see. So we'll start the public comments with, I presume, Jeff Giddings. Jeff, are you up first? Okay.
Yes.
So okay, good, excellent. And this will, and then Richard Bryan and
And they're on behalf of Syngenta.
Syngenta, right. Okay,
Right,
so
crop
we'll
protection.
go with Dr. Giddings first.
Okay. 1 second, and William, do you have the clock set up?
I can keep time.
Okay, great. Dr. Giddings,
Ready
you
to
may
go?
proceed with your presentation. Thank you.
Well, thank you. First, to introduce myself, I'm an aquatic ecologist by training. After grad school, I spent 10 years at Oak Ridge National Lab doing research on metals and oil spills in microcosms and mesocosms. And then 10 years after that at a environmental contract lab, which was called Springborn at the time and is now Smithers, where I was directing GLP mesocosm and microcosm studies for clients in the ag chem industry. But my association with the atrazine cosms began in the early 90s. Coincidentally, it was around the time that EPA stopped requiring GLP mesocosm studies for FIFRA registration. But this was when Syngenta's predecessor, the atrazine registrant, asked for my assistance to compile results for all the available atrazine cosm studies that we could find. This is in preparation for the triazine special review. And so we put together an annotated compilation, which was intended mostly as a map of what was out there, so we would know what we were starting from. And it became the basis for the database that was first presented in an appendix to the 2003 MOA. And then it was again presented without changes in EPA's white paper for the 2007 SAP. So I've been working on these for a while. The database evolved from there with additions and modifications and revisions, as you've heard. But I continue to examine the database through this time with my colleagues, and we published our results in a book in 2005. We've published them in an open literature publication in 2018, but also reviews and analyses that we've submitted to SAPs in 2009 and 2012, and reports and comments that we've submitted to EPA throughout this time, most recently in 2022. And I'm pointing this one out because I think it's attached to Syngenta's comments that were submitted for this SAP, which was a complete reevaluation of the atrazine data and database. And I'll be referring to that. I'll call it Giddings 2022. That was the authorship of it. And I'll be referring to that from time to time just to show you how the conclusions that we reached in that agree or disagree with EPA's. Okay, well, anyway, it's a pleasure to see that the database continues to be improved, and I'll say up front that we agree overall with virtually every one of EPA's changes on these 11 studies. Next slide, please. Okay. So as you've just heard this morning and this afternoon, that EPA's reevaluation rescored or removed many effect endpoints at low concentrations. And I've just listed them here, summarizing what you've just been hearing. Let me go through them one by one and explain our take on them. As I say, we agree with all of the recommendations of the EPA, but we disagreed on a number of smaller points, which are included in our written comments. But to start with Lampert, this study's been at the top of the list of questionable studies ever since the early history of the COSM database, primarily for two related reasons. One is because those concentrations are extreme. They're much lower than reported effect concentrations from lab studies or from reliable other COSM studies. So because of the low concentrations, these attracted considerable attention. And plus the fact that the published paper was, let's say, vague about methods and results, and it was very difficult to really understand what had been done and what the results were. So this has been debated now for more than, well, at least 20 years. The observations have been well explained as likely due to the effects of the solvent. And you've just heard how that this morning how that was concluded. But there were other important problems with the paper itself, as has been clear. First of all, a lot of the important details weren't presented in the English paper, as you've heard. They were presented in a dissertation in German, which was only, I think, recently translated. We had access to a portion of the translation quite a while ago, which did confirm that ethanol was used in the study. But some of the other things that have been pulled out and presented in the white paper from the full translation of the Fleckner dissertation are very important, and they really do confirm the importance of, or the likelihood that the solvent was what contributed to most of the observations from that study. But the study was unreliable for other reasons, like serious reporting deficiencies. It was difficult to know what had been done. There were, of course, inconsistencies between Lampert and Fleckner's thesis. There were weak or inverted dose-response relationships, presumable enclosure effects, timing inconsistencies, and a number of things that we had actually, before we even really focused on the solvent as been an issue, because that hadn't been confirmed, we had these other problems with this study, and we talked about them in the 2005 book, and they were noted. Actually, all of these other deficiencies were noted in EPA's Open Literature Review Summary, which was in 2009. So there were a lot of problems with this study, and we're very much in agreement with EPA's decision to exclude it from the analysis. The Kansas studies, I think you got a good flavor from the presentation earlier about the complexity of understanding this set of experiments. They were reported in a large number of publications, and one reason why it was difficult to track down what each endpoint represented was because some of the publications that were cited in support of that endpoint early on, especially, really didn't relate to that endpoint. And so it's taken a lot of untangling, and EPA has done a good job of that, untangling which studies were done in which years, and some of the real small details that would reflect on the usability of some of that data. So, so that's really, well, two things to note. One is it's a really hard set of studies to understand, and we've been trying to do this for about 30 years, trying to interpret this complex of studies. But I believe that we have now, with this reevaluation, we've come to an agreement on how the scoring should be and how the lumping or splitting of the data points should be. In both of these experiments, both the 79 experiment and the 81 to 83, or the 81 part of that experiment, there were weak or slight transient effects on phytoplankton and no effects on macrophytes at 20 micrograms per liter. And so those two endpoints were rescored from effect to no effect, and we're very much in favor of that. I think there's an error in this slide. It says that 2 endpoints were removed from the 79 studies, and 2 were removed from the 81 to 83 studies. Actually, there weren't any 79 endpoints removed, and there were 4 81, 83 endpoints removed. And they were removed for various reasons, as you've heard. 2 of them were because they were from the 82 portion of that second study, and that was considered beyond the duration, the acceptable duration for the data. One of them was taken away because it actually duplicated another one, as you've heard, and one was taken away because of lack of replication. So those are the 4 Kansas endpoints that were taken away, and but we're left with these 2 20 microgram per liter no effect endpoints. And we agree with all of these conclusions. For Dettenbeck, you remember this is the one with the wetland, flowing wetland streams, where the concentration, the atrazine concentration was increased stepwise during the course of the study, 15 days at 15 micrograms per liter, and then another stretch of time at 25, and then increased up to 50 and 75. And as you've heard, that experimental design really confounded the interpretation of the results, at least beyond the 15-day 15 microgram per liter phase, before these stepwise increases started to happen. Even at the 15 microgram per liter, we had, in our analysis through the years, concluded that there were not any consistent effects at 15 micrograms per liter. Things that were seen as effects or claimed as effects on one endpoint or another at 15 micrograms per liter didn't show up at higher concentrations. So the dose response relationships were weak. So EPA excluded this study because of the lack of detail about methods and results, and because of the difficulty of interpretation of this stepwise study. And we agree that the study is of very low quality and that the interpretation is reliable. So we agree with that decision as well. Notice that takes out two more low effect endpoints at 15 and 25 micrograms per liter. Kosinski and Merkel, very difficult experiments to tease apart. As you heard, the experiment was actually repeated twice using communities from two different sources, but previously only one experiment was represented in the database. This was the Little Brazos, if you remember back that far. In that experiment, the endpoints at 10 and 100 micrograms per liter were scored as effects. But in their reevaluation, as you've heard, EPA rescored the 100 microgram per liter endpoint to a no effects because the effects were slight and transient. They kept the 10 microgram per liter scored as an effect. And frankly, we did as well in our reevaluation last year. But we do have real concerns about that effect at 10 micrograms per liter because there were clearly differences between the cosms that ended up in the pre-treatment differences between what became the atrazine treatment and what became the control treatment. There were differences among those cosms even before the treatment began in the what they called the chronic 10 microgram per liter exposure. We're really having trouble understanding EPA's interpretation of the timing of the data as it's presented. The data for both you remember this, well, maybe you don't remember, but to remind you, this started out with a 10 microgram per liter chronic exposure, continuous exposure at 10 micrograms per liter for 3 or 4 weeks. And at that point, both the 10 microgram per liter and the control cosms were then treated with a single input of higher concentrations. 100, 1,000, and 10,000 micrograms per liter. During that 10 microgram per liter phase, actually 1 week and 1 day before that 10 microgram per liter chronic exposure began, there were differences between the two sets of cosms. EPA has, however, this was not clearly explained in the paper itself, and it was ambiguous as to what that meant. And I believe that in the presentation today, it was said several times that day 0 always meant day 0 of the acute exposure, which would mean the day 0 would be at the end of the chronic exposure. But that's because in our interpretation, it's just because of very murky writing and presentation in the paper. Day 0 in the chronic exposure is day 0 of the chronic exposure. 1 week before and 1 day before, or 1 week and 1 day before the chronic exposure began. And it's just not logical to say that those two numbers refer to measurements that were made at the end of the chronic exposure and that they refer to a week and a day before the acute exposure. just doesn't make sense. And if you look at the data, it was presented in slide 22 of what EPA presented this morning. It just does not make sense in the way they've interpreted it. And it really looks like there was a difference between these two groups even before the atrazine treatment began. The difference went away then for a few days and it returned later on. And because of that, we've cautiously interpreted that as an effect. The fact that the pretreatment apparent difference was there, but went away. So we figured we'll be conservative on this and interpret the later divergence as an effect. And but it's a very uncertain interpretation. One would really need to go back and dig into this discrepancy about the timing of these samples and whether or not those pre-treatment differences really might have affected the differences that occurred later on at 15 micrograms per liter. So bottom line, we accepted 15 micrograms per liter as an effect in our reevaluation, but we're quite in agreement that the study is weak, and if EPA wishes to exclude the study entirely, that sounds like another reasonable way to deal with it. We kept it in, we gave it a low data quality score. I believe I may have just shifted a cog between Dettenbeck and Kaczynski and Merkel. But let me get back to Kaczynski and Merkel. In the first study, as I mentioned, there were endpoints that were scored as effect at 10 and 100 micrograms per liter. In the second study, which had not been initially represented in the database, the two new endpoints were scored as no effect, and they were added as two new no effects. So generally, then we agree with EPA's reevaluation of the Kaczynski and Merkel endpoints, but we do have concerns about that 10 microgram per liter effect in one of the studies, which we think may have been an artifact due by pretreatment differences. As far as the two Seguin studies, don't have too much to say about that. Clearly the successional dynamics in the 2 microgram per liter treatment made it really difficult to interpret the effect that was apparently observed at the end of the study. And we are in agreement with EPA as rescoring that endpoint, that 2 microgram per liter endpoint. I think I've got this wrong on the slide. The endpoint that was rescored was the 2 microgram per liter. And then also removing the two duplicate endpoints at 2 and 30 that were actually just because the study had been reported phytoplankton in one paper, paraphyton in another. We always looked at that as one study, and we separated them originally because they were two different plant groups. EPA says that they are now separating it because they were thought to be two different studies. At any rate, we're now down from 4 endpoints to 2, and 2 of them, which had been previously listed as effects, are removed. And finally, Seguin 2002, no change in the interpretation of that. We feel that the interpretation of the data pretty clearly show effects on multiple endpoints, and so we do agree with EPA's interpretation of those results. So we end up agreeing with all of these EPA's conclusions, although we differ on some of these technical details. It was mentioned this morning that when they did in the 2012 SAP report, when they listed all of these studies as deserving further attention, there was some comment that they said that if EPA accepted all those points, then there wouldn't be any other examination needed because they agreed with all the others, which might have been true, or apparently was true in 2012, but there were points added after that SAP. There are points that were not in the database at the time of the SAP that are in there now that deserve attention. And I'm going to talk about 2 of those. Next slide, please. The study by Pannard et al. In 2009 and the study by Baxter in 2011. Now, these studies have been completed and published, in 2012, but they hadn't yet been reviewed and incorporated into the EPA database. They weren't considered in the 2012 SAP. So, of course, the SAP made no comments on these, but they are very important and controversial endpoints and need to be reviewed. Next slide, please. So let me start with Pannard et al. These were barely COSMs. They were laboratory systems, about a cup of culture derived from a natural community, which is what made it count as a COSM, because it had an actual phytoplankton community. It wasn't just a single species, but it was maintained in a semi-continuous culture where medium is added at a constant rate. The culture inside the vessel comes to an equilibrium with the input rate. And at that point, you can say various things about the dynamics in the system when it's at equilibrium. This culture in this study was allowed to reach an equilibrium at a low phosphate input rate before the atrazine treatment. And it would have been a great way to look at the effects of atrazine under, conditions where everything else was in equilibrium, but they increased the phosphate input simultaneous with the beginning of the atrazine treatment. So from then on, everything that happened was really more a response to the phosphate input than to these, as you see, fairly low atrazine concentrations. So if the effects of atrazine, if there were any, couldn't be seen against this background of the response to the altered nutrient regime. So next slide, please. The slide on the panel on the bottom shows the effect, or I'm sorry, the growth of phytoplankton over the course of the study. There are 4 lines there, but they're all overlapping because there were no differences between the control and any of the atrazine treatments. And this, what you see here is what you would expect in a continuous culture at equilibrium. If you increase the nutrient input rate, as was done, the biomass in the culture will increase until it reaches a point where it is now taking up all the additional nutrients. And so that's just what you see with that chlorophyll graph on the bottom. The one on the top shows photosynthesis, which normally would be pretty much in line with chlorophyll, and it was for the first 4 weeks. But then for some reason, which is unexplained, photosynthesis declined in all the COSMs, including the controls, even though biomass did not. So it's not clear what's happening there. But what is clear is that there are no any differences between the treatments in photosynthesis are weak and they don't last. So our conclusion, no effect on phytoplankton photosynthesis or biomass in these studies. Next slide, please. There was an apparent effect on phytoplankton diversity, although the way it was described in the paper, it's almost impossible to know whether this is an increase or a decrease. But taking it at face value on this graph here, the controls you see decreased in diversity after the nutrient addition, which is what you would predict from a system with an increase in nutrients. The diversity would decline. The 3 lines above that, supposedly representing the atrazine COSMs, looked like an increase in diversity. If that's real, well, is that considered an adverse effect or not? But also in trying to figure out if it was real, looking at the changes in abundance of individual species, there weren't any significant dose-related effects on individual species. So it's really not clear what this index is saying. Next slide, please. We reviewed every paper for data quality, for relevance and reliability, and you can see the criteria that are shown here that we used. It was ended up being a 20-point scale, and this study, the Pannard study, scored the lowest of all the 40 studies that we reviewed. You see it had a score of 0 on relevance because of the small size, the reduced ecological complexity, the unrealistic continuous atrazine exposure. So we gave it a very low score for data quality. Next slide. So overall, we gave this a low data quality score. We interpreted that there was no demonstrable effect at 0.1, 1, and 10 micrograms per liter. Next slide. Okay, so that's that. I'll come back in a minute to what that does to us. But you see that removes several very low concentration endpoints from the database and will definitely affect any LOC calculations. The other study I mentioned was Baxter et al., which was sort of the exact opposite of the simplified laboratory study from Panard. The Baxter study was large outdoor tanks with water and sediment from a pond. It had 2 species of macrophytes in pots so that they could be measured and monitored more carefully, caged and free-living snails. It was all designed to address a hypothesis that effects of atrazine on phytoplankton, periphyton, and macrophytes would be related to changes in trematodes and success of snails. That's another story and won't go into it now, but as far as just the effects of the atrazine, so the cousins were acclimated for 7 weeks and then treated with doses of 1, 10, 30, or 100 micrograms per liter, and then monitored for an additional 70 days. Next slide. So these are the results. There were no effects on periphyton or phytoplankton ash-free dry weight. Next slide. There were effects at the highest concentration on macrophyte dry weight. And you see the asterisks there at under 100 micrograms per liter, where these potted macrophyte growth rate or weights at the end of the study were different from the controls. No statistical difference in the other treatment groups. In 2016, EPA said they considered that the 10 and 30 microgram per liter groups were biologically significant, even if they weren't statistically significant. And so they scored as effects all 3 of the higher concentrations in this study. We disagree with that. It's not clear that that's substantiated by the data that are shown here. So we think at the very least this needs to be re-examined in the same way that EPA has just done a great job of re-examining the other studies to see whether those effect scores should be changed. We believe they should. Next slide, please. Again, this score, the Baxter study was one of the highest in data quality, and we believe showed no effects at 1, 10, and 30 micrograms per liter. Next slide, please. So just one final comment here that we're not supposed to talk about LOCs, but it's clear that when you remove the low quality data, especially the low quality data at low atrazine concentrations, the LOC will increase. So the 2016 ERA proposed an LOC of 3.4. We don't know what these latest set of revisions will do to that LOC, primarily because we don't know how EPA is calculating LOCs anymore. But we do know what it looked like when we examined what I call the G22 database, the database that was in the 22 report that I've been referring to, which made all the changes that EPA has just made the changes I've mentioned for Baxter and Panard, made a few other minor changes in scoring and lumping and splitting, but basically using all of the data that are in that database, which included even the really low quality studies, we got an LOC of 11.7. That's basically a matter of rescoring. If we remove the low quality studies, which is about half of them, the LOC that we calculated, this is based on parts per billion days, which may not mean anything to you yet, but it's how the LOCs can be calculated. And it got an LOC of 14 micrograms per liter. And there's still an element of uncertainty, even using the high quality studies, in that this is a 60-day LOC, and many of these studies did not last that long. And so results and effects and exposures over a short period had to be extrapolated out to 60 days for use in the analysis. That extrapolation, in some cases, introduced a lot of uncertainty and distorted the picture. If we remove the shorter studies, remove those 10 shorter studies from the database or from the analysis, we get an LOC of 19.8. So again, the point is that as you refine the data and focus on the high quality data, it happens with the atrazine database that the LOC increases. Next slide, please. Just to summarize then, we agree with all of the specific data revisions proposed in the white paper. We think that EPA really should evaluate these Pannard and Baxter studies because they have they were not present in the 2012 SAP, and they have a substantial influence on the LOC calculations and need to be examined the same way these others have. And finally, just an overall recommendation that a systematic evaluation of data quality is really important, especially in a data set like this. As been pointed out, there's a lot of different kinds of science going on here, and some of the data should carry a lot more weight than the others. And that's something that needs to be done more systematically and transparently than is now the case. Thanks for your time.
Okay, so I've got your Richard, I've got your last name listed 2 different spellings in the under your name on the screen. It's Brain, and on the paper it's Brian. So I don't know how to address you except as Richard, and so I'll say you're up next.
Well, that's perfectly fine with me. Is my audio working?
Yes, yes, it is.
Okay, good. Well, first, I'd like to express my appreciation to EPA and the panel for the opportunity to present today. I'd also like to acknowledge the agency's white paper, which was very thorough and rigorous. A little bit of background. I've been an environmental toxicologist with Syngenta for over 14 years. Incidentally, I've been working on atrazine for over 14 years. And this is actually my second SAP related to atrazine. The last one was in 2012, although many others have experienced several more than that. So if you transition to the next slide, please. Basically, just to give you an overview of the content. What I'm going to do is try to provide a little bit of context around the LOC, discuss a little bit about the composition of the data set, and then I'd like to address the importance of systematic and consistent data quality and relevance criteria in terms of identifying best available data, explore the sensitivity of the CELOC to scoring and selection of data points, particularly those that ascribe effects to atrazine below 30 parts per billion, primarily those that are the content of this particular science advisory panel. Then I'll address the consequences of not using best available data and what that could mean in terms of risk management. And then also finally, just it may sound peripheral, but I'd like to address the relevance to other taxa, simply because the chronic endpoints, for example, for fish and amphibians, have relevance to the aquatic level of concern based on the hypothesis underpinning the LOC, and that LOC is directly dependent on the COSM database, which is relevant to the SAP at this time. So if we go to the next slide, please. So essentially, the CELOC has evolved along with the COSM dataset over time. And there's been multiple iterations of interpretation, analyses, revisions. And I'm going to highlight some of the milestones that have been associated with that progression. And I'd also just like to emphasize the fact that the scoring and selection of the COSM data set is ultimately what determines the level of concern. The methodology used to interpret the data set into a 60-day CELOC is really irrelevant because it's calibrated to the same data set. So the scoring and selection is paramount. And previous analysis have suggested a level of concern somewhere between 10 and 18 until recently. And then one significant change that occurred was in 2012 when EPA transitioned away from the Brock scores, which was a 5-point scoring system of no effect and then significant effect, but with various, lengths of time for recovery, and then significant effect without recovery. That was transitioned to a binary delineated data set, effect and no effect. And then there was the introduction of the plant assemblage toxicity index as a method to translate that data set into a CELOC, which suggested a value somewhere between 4 and 7 at the time. The subsequent science advisory panel had suggested some concerns with the database, particularly those studies ascribing effects to atrazine below 30 parts per billion, which is primarily the focus of this particular SAP. And also, I'd like to point out that the SAP also recommended the conduct of a definitive COSM study that was reflective of second and third order streams in the Midwestern US. And that study was subsequently conducted and also published in 2016, looking at pulse exposures up to 150 parts per billion. And I'll address that in a little more detail here in a minute. And then finally, in 2016, the draft ecological risk assessment was released, suggesting a CELC of 3.4. However, it's worth pointing out that that particular analysis did not incorporate the recommended changes to the data set as proposed by the 2012 SAP. And then in 2016, there was a couple of analyses that were conducted by Dr. Dwayne Moore and Dr. Jeff Giddings. These were systematic reviews of data quality and relevance, scoring them accordingly, and then looking at the weighting of those in terms of the outcome of the level of concern. And then, as alluded to by Jake Lee earlier today, the atrazine LOC was revised to 15 parts per billion in 2020. And then that was retained through the preliminary interim decision, if we go to the next slide, and then also in the interim decision. Next slide, please. And then finally in 2022, EPA released remanded the ID and basically released a new position suggesting the LOC of 3.4 parts per billion, and then due, I think, in part to the extensive feedback provided, has convened this SAP today to evaluate the COSM data set, and rightfully so. So if we proceed to the next slide, please. And so the atrazine COSM data set is prolific by any standard. In fact, I'd be willing to bet that there's more COSM studies for atrazine than there are for all other pesticides combined. And one thing I'd like to point out is that unlike the Declaration of Independence, not all studies are created equal. And this is an important distinction. They vary in design, scope, scale, quality, relevance. Some are lodic, some are lentic, some are limna corrals, sectioned off lakes, some are diverted streams. And so you have a spectrum of relevance and a spectrum of quality, in fact. And if you look at, this comparison, effectively you've got, a beaker or flask of algae, which represents a very low resolution representation of reality, versus a fully simulated stream study, which reflects a very high resolution representation of reality. However, in the COSM data set, these two are treated as equivalent. They're not weighted or scored in terms of their quality and relevance. And so I'd like to focus just a little bit, if I may, on the study that's in your lower right panel there. That is the Baylor Experimental Aquatic Research Facility at Baylor University. This is the study that Professor Ryan King performed, a pulse atrazine study. And the reason why that's important is because it was done to the specifications of the SAP. They wanted to see a study that was in a flowing system, representative of the watersheds in which these second and third order streams are located. They wanted a pulsed exposure, and they wanted to see a replication. And so that's primarily why we chose this facility. And, full disclosure, I actually worked on this facility as a postdoc, so I was familiar with it. Basically, it is, there is 12 streams. They're 20 meters long. They have riffle, run, and pool sections. They're concrete culvert pipes that have substrate, and then they have artificial substrate tiles, which I'll get to in a minute. The water source actually is from a wetland that polished water comes out of the Brazos River, so it's pretty clean. And the endpoints that were measured in this study include everything from periphyton, grazed, ungrazed, because we had caged minnows for grazing in the glide section. There was periphyton analysis. There was macrophytes in the pools, ceratophyllum. We looked at metaphyton, just a host of structural and functional endpoints. And there were data sondes that were deployed in the pools to evaluate dissolved oxygen, water quality, chlorophyll A, et cetera. And the atrazine was actually metered in through peristaltic pumps at the headwater of the stream. And that was done at pulses of 50, 100, and 150 over the course of 7 days. And that was sequentially repeated 3 times during the first 30 days. So there was 3 pulses. And then essentially there was a 30-day recovery period to look at whether or not there was resumption of growth and the return of the structural and function endpoints to control levels. And so the streams also employed the same ISCO data samplers or auto samplers that are utilized for the atrazine ecological monitoring program that took samples of the water consistently throughout the day to ensure that the dosing was accurate. Which is no trivial feat when you're trying to achieve pulsed exposures, multiple pulsed exposures at different treatment levels. And so anyway, that was sort of the methods, I suppose, of that particular study. Then if you go to the next slide, and these are just a couple of example results from the study. And in retrospect, I wish I'd included the dissolved oxygen response because it showed a very elegant dose-dependent reduction of dissolved oxygen during the pulses. And I'd encourage you to reference the manuscript for more details on that. But effectively, by the end of the study, there was virtually no significant effects on structural and functional endpoints, with the exception of, I believe, metaphyton. There was a slight increase in metaphyton in the control pools that resulted in a slight increase in DO because that's where the data sondes were employed or deployed. But that was likely due to asynchronous sloughing of the metaphyton mass in the streams at that time. So the point of this discussion is that despite the fact that the level of sophistication and despite the fact that the SAP had requested this particular study and it was done to their specifications, it's basically treated as equivalent to a flask of algae. And I think there's some fundamental concerns with making that equivalence. And so I would encourage, more rigorous scoring of data quality and relevance and weighting of the studies to properly determine a level of concern. Next slide, please. These are just here for reference for the panel to access at their convenience if they're interested, relative or relevant to what I've just been describing. So next slide, please. So I'd just like to point out that the systematic and consistent application of data quality and relevance is paramount because without that, you cannot identify best available data. And that has implications because if you're relying on lesser quality studies, you may come to erroneous conclusions regarding potential risks, which may then result in inappropriate or unnecessary risk mitigations by risk managers. And so I think it's important to develop a priori the criteria by which studies are going to be evaluated those should be discussed, those should be debated, and agreed, and above all, transparent. And so I would encourage the agency to implement a more systematic data quality evaluation that utilizes scoring to rank, order, or weight studies accordingly. Next slide, please.
Hey there.
And there are, again, just a number of recommended sources here. The analysis I mentioned earlier by Dr. Dwayne Moore and Dr. Jeff Giddings, as well as other studies that have employed rubrics and a priori criteria to assess, score, weight studies. And again, this is just for reference, and you can access these at your convenience. Next slide, please. So I wanted to get into just a little bit about the sensitivity of the CELOC. And again, this is particularly focused on studies describing effects of atrazine to low atrazine exposures. And so what we did was we performed an analysis, and it was predicated on the memorandum that Jake had mentioned earlier, where in Appendix A, EPA had provided a series of permutations that was based on the 2012 SAP recommendations, and they had various combinations in there of scoring something as an effect versus a no effect, also selecting certain studies for an inclusion or exclusion. And so there's multiple different scenarios. And so we utilize that, we use that as the basis for the analysis, where we employed the plant assemblage toxicity index. Now, this is the version we got in 2016. So we're not sure if it's the exact same version was used in 2019. But, if you look at the base case there at the top, I mean, the CELOC in the preliminary ecological risk assessment was 3.4. We came to almost 3. So we thought, there's pretty good agreement. And then we went through all the various permutations. And I should point out that the analysis also utilized the EPA generated exposure profiles that had been provided previously. So, we were using basically the same data set and the same exposure profiles, just going through the permutations. And you can see, if you look at the CELOC column, just the profound influence that, various combinations of scoring and selection have on the outcome of the CELOC. And the reason why I've highlighted that row in the bottom in red is that this is, if you perform this same activity on the data set that the G22 that Dr. Jeff Giddings was just describing, which basically reflects the consensus opinion of the 2012 SAP and broadly reflects the position of EPA on the 11 COSM studies, but also addresses the Pannard and Baxter endpoints, just for clarity, you end up with the number of 15, which is effectively what the current LOC is. So if you go to the next slide, please, you can see this graphically. And the only reason I place this here is just to give the panel some context for what this looks like when you do a binary delineation of the data. You can see, up in the top left, that if you have a number of endpoints that are purporting to have atrazine to have an effect, a very low concentration, it tends to skew that binary regression or that nonlinear regression down relative to whether or not those endpoints are incorporated or they're rescored. And so this just shows you, basically doing the analysis per the 2012 SAP and addressing Pannard and Baxter, you end up with two very different numbers. And so this is just to highlight the sensitivity of this methodology to the scoring and selection. So next slide, please. So in terms of the consequences of best available data or not employing best available data, if we look at an example where we utilized the WARP MP model, and just to qualify, it's our position that this model wasn't designed to predict water concentrations like the pesticide water calculator is designed to rank order watersheds. But leaving that aside, utilizing that model and correcting the average rainfall, the total rainfall, and also applying the parameterizing just to watersheds in the Midwestern US and not nationally, and further details of that in our comments, but it's peripheral to this discussion. What you end up with at an LOC of 3.4 is basically you're incorporating over 40% of national corn acres in the US. Whereas at an LOC of 15, it's 6%. That has huge implications for growers, and that has huge implications for agriculture. And that's just basically to demonstrate, again, the importance of data quality and relevance and scoring them accordingly. And so, again, just implications for risk management. So if you go to the next slide, please. And again, I appreciate this is a little peripheral to the LOC discussion. However, the chronic endpoints are relevant because the hypothesis that the CELOC is predicated on is that primary producers, algae and aquatic macrophytes, are the most sensitive taxa and therefore protective of higher taxa. And if you have a case where an endpoint for chronic endpoint is lower for fish and amphibians, in this case, that could cause confusion. And I believe there were some comments related to this that were submitted by the Center for Food Safety. So I just like to spend a little bit of time looking at fish and amphibians, one slide each. I understand they're very dense. I was not anticipating having as much time as we had. But what I want to point out is that, for the amphibian database is as complex and as variable as the COSM database, if not more so. There's been 3 SAPs held. The 2003 SAP indicated that there wasn't sufficient information to come to a definitive conclusion on whether or not atrazine caused reproductive effects in amphibians. So the recommendation was to conduct a definitive study, which was done on 2 continents in 2 different labs simultaneously under GLP conditions. And just for note that the protocol was developed in coordination with EPA, and I believe EPA oversaw the studies and audited those labs. It also contributed to development of the amphibian metamorphosis assay. So it's a very robust study on Xenopus laevis, indicating no effects up to 100 parts per billion. Now, up to 2016, EPA had held the principle it would only use quality data to define a chronic endpoint for amphibians. And just for reference, the agency actually did a pretty robust analysis of data quality in the 2012 white paper for amphibians, and basically scoring them according to quantitative, 3 levels of qualitative, high, medium, low, and then inappropriate. And so, and the outcome of that was that there was only 1 study that was quantitative, and that was the study that was done to address the SAP that was held previously. However, the 2012 SAP expressed concerns with relying overly on 1 study, and fair enough, and suggested that the agency, do sort of a weight of evidence approach. However, the 2016 risk assessment basically incorporated all the data points except for those that were defined as inappropriate, despite the fact that they were previously ranked in terms of quality. And so if you do that analysis, and there's been a couple of those quantitative weight of evidence analysis by Glenn Vanderkraak and Mark Hansen, for example, you arrive at a number that is much closer to 100. The reason why that's important is because the existing endpoint of 3.4 would be lower than the current level of concern, whereas a number based on a more robust and rigorous analysis would be much higher than the level of concern. And I'll just give one last example on this on the next slide. So the fish chronic endpoint is currently 5 parts per billion. And this was based on a study that had notable deficiencies. It was done in a non-GLP lab, did not follow a standard protocol. It did not have the recommended sex pairing ratio 4:1 versus equivalence under OECD 229. Overall egg production was low, et cetera. And all of these deficiencies were identified in the agency's data evaluation record, which concluded qualitative. However, it was used quantitatively, but more importantly, the study was used exclusively. And the reason why I found that a little concerning is because there was a GLP compliance study that repeated the previous study with deficiencies, basically addressing the GLP consideration following a standard protocol, and having the correct sex pairing ratio of which actually results in a 30% impact to egg production. And so this study found no effects up to 50 parts per billion, the same concentrations as the deficient study. It was mentioned in the 2016 risk assessment, but it wasn't used. The previous endpoint was 65 parts per billion, which is based on a trout fish full life cycle study. And there's been multiple fish full life cycle studies with fathead minnow. There's been fish short-term reproduction assays, multiple ones with the Medaka, which is the species in question here. We even did higher concentrations of that. Zebrafish, early life stage studies, all GLP compliant, all in accordance with standard protocols. Yet that information was basically not utilized in a weight of evidence framework to derive an endpoint. And the impact of that is, well, 5 parts per billion is less than 15 parts per billion. However, the previous endpoint again was 65 parts per billion, which was based on a pretty robust study. And so there's concerns about, the application of data quality and relevance, which, I would encourage that to be revisited. But those are just some of the peripheral ramifications. So I'll wrap up on the next slide, my final slide. And basically, this is just recommended sources again for the panel if they're interested. Those studies that I mentioned. But finally, the data set has evolved. The CELC interpretation has evolved. It's been between 10 and 18 until recently. And it's being recommended to be reduced. The micromesocosm data set does vary considerably in terms of specification, design, quality, and relevance, and those studies should be weighted in accordance with those criteria. The application of systematic data quality and relevance criteria, I can't stress enough, is paramount to identifying best available data. If you don't do that, then you can have unintended consequences for risk management that impacts agriculture, for example. The CELC is very sensitive to the binary delineated data set, particularly those studies describing effects to atrazine at low concentrations. When the best available data are employed, a CELC is indeed protective of other taxonomic groups. So that's the relevance piece. And I'll leave it at that. And thank you for your time.
All right. That was the first set of public comments. And now we're going to move to the folks from the Triazine Network. And I've got Gary Marshall up first. Is that right?
It is. Can you hear me?
Mr.
Yes.
Marshall, I sure hope that you guys are not going to spend a lot of time talking to us about stuff that we're not going to be discussing this week.
Well,
I'll
we'll try not to spend.
I'll let you get to it.
All right. I'm going to be pretty brief myself, and then we'll have an opportunity for you to visit with our scientist who's been heavily engaged in the issue. But I do think it's important that the panel has an opportunity to hear from us. Again, I'm Gary Marshall. I'm formerly the CEO of the Missouri Corn Growers Association for 34 years, but I also serve as co-chairman of the Triazine Network. And I've been doing this since 1994. And in actuality, this is my fourth SAP that I've been able to offer testimony to. So been engaged in this process a very long time, heard a lot of the arguments, pro and con, back and forth. And it's just really a great opportunity to visit with you just a little bit and talk something about what the EPA has proposed through their white paper. Now, the Triazine Network is a group of farm organizations that go all the way from Maine to California, from Florida to Washington State. We encompass all different kinds of crops, including sugarcane, sorghum, turf grass, citrus, all the way to corn. And so it's a role that we play, and we feel is extremely important because we play a role between the EPA and the registrant. And we think it's the voice of the American farmer that really needs to be heard in this process. And the EPA has allowed us to participate over the years, and we certainly do appreciate that. We've had a lot of experience at Missouri Corn in working on water quality and product stewardship projects over the years, helping to develop best management practices, which allow us to keep the triazines on the field and out of the waterways. And our growers have a very, very strong commitment to sustainable use of atrazine and the triazines. Atrazine is virtually irreplaceable as a long-lasting herbicide, offering weed control in conservation tillage and no tillage farming practices. And farmers have a strong commitment to that sustainable agricultural production. We like using no-till and minimum till because it helps sequester carbon, builds organic matter in our soils, and provides cover for the soil to prevent runoff and erosions. And without atrazine's long-lasting weed control, many farmers would have to resort to something else that would harm the carbon-sensitive, sustainable farming practices that we currently use. So I want to give you two reasons why we're heavily involved in this process. Number one, just on the corn industry alone, atrazine is used on approximately 2/3 of all the acres of corn grown in the United States. And that calculates out to about a $2 billion cost to switch to a different product that would offer less weed control and cost more. $2 billion every single year. That's why it's important to corn farmers, and that's why the corn growers are involved, but it's also extremely important to the other groups that I'm sure you'll hear from in the next day or two. The second point is that our farmers live and have lived for a number of years in a lot of the sensitive watersheds that EPA has concerns about, as do we. The farmers have the most concerns because they live there. But I have to tell you, at some point in time, the models and the work that you folks are doing looking at these various studies, they need to reflect the real world conditions. And in the real world, our farmers have been using atrazine in a lot of these sensitive watersheds for over 50 years now, and they still see robust numbers of fish, algae, plants, amphibians. You know, it is really like today, like it was 30, 40, 50 years ago. So that is the second reason why we're heavily involved, because farmers want to know exactly what's going on, and they want a strong, robust science used to evaluate these different farming practices that we have. Now, as you know, this is a science advisory panel. I'm not a scientist. I simply ask that the panel ensures that these poor quality scientific studies are not used, and to consider the importance of sustainable carbon smart farming practices that we can do with the use of these types of products. Finally, you're going to hear from Dr. Dwayne Moore, who's a scientist who has worked with the network for a number of years. We asked him to review and evaluate the July white paper that EPA put out for us. And he completed a comprehensive analysis of the actions on atrazine, and on our behalf will present his findings on the points made in the white paper. So as panelists, you're going to look at the science, and as farmers, that's what we want. We want the science to be right. So if you do, and if the EPA does what we've always asked, which is follow the science, I'm sure our growers are going to be very, very pleased. And with that, I'm going to turn it over to Dr. Moore and let him talk in a little more detail about the science. Thank you.
Thank you.
Well, I can start with a quick overview of what I'm about to talk about. So I'll start with a few slides on why we believe scoring COSM treatments is very important, as well as determining what should be in the database and what should not be. Talk a little bit about the EPA's white paper. A lot of that ground was covered by Dr. Brain and Dr. Giddings, so I won't spend too much time on that. And then what I want to talk about is thinking about next steps. Where do we go from here, and talking about a weight of evidence approach for developing an LOC for atrazine. So still no luck getting it up. Ah, there we go. Perfect. We can go to the next slide. So most of you have heard this already. Since 2003, level of concern derivation, whoop, went too fast. Previous page. There we go. Have relied on an extensive COSM database that includes over 70 COSM treatments altogether. In the most recent iterations for deriving the LOC, EPA has relied on the Plant Assemblage Toxicity Index, or PATI. And as Richard pointed out, that is essentially a calibration exercise. And so it is really the COSM studies that are in the database and the treatment scores for those COSM studies that are the drivers of the LOC values, not the method. And EPA's LOCs, as Richard showed, they varied through the years, but they have generally been lower than what have been published by myself and Jeff Giddings. And really it comes down to differences of opinion regarding which studies are in the database and the effect scores for individual treatments. I think that's become readily apparent by now. The COSM studies that are the focus of this SAP are the primary source of the differences of opinion, although as Jeff pointed out, there are a couple more studies that also require an in-depth review and evaluation, such as was conducted in the white paper. And just to reiterate the point that scoring makes a difference and decisions on controversial COSM studies make a difference. In 2012, EPA proposed an LOC of 4.2 micrograms per liter. As we've all heard, the SAP had concerns regarding some of those key COSM studies, and in fact, that's why we're here, and the associated effect scores. But using the same method that EPA used in 2012, but accounting for the SAP recommendations on those controversial studies, Jeff Giddings derived an LOC of 25 micrograms per liter. So it all comes down to which studies are in the database and their associated effect scores. Next slide, please. So to go to the focus of this meeting, I fully concur with previous comments that EPA has conducted an in-depth and excellent evaluation of the controversial COSM studies. They uncovered details that we were unaware of before. I think piecing together what happened with the University of Kansas studies was a very difficult endeavor, and it was well done. And I also like to commend Dr. Lowett, Dr. Goldsnow, and Dr. Ferrugia for excellent presentations this morning and early afternoon. They're very logically laid out, and for those of us who have OCD like me, I appreciated it. Very well done. And ultimately, the recommendations that they made, as Jeff has noted, and the effect score changes are in accordance with recommendations from past SAPs and other reviews by Jeff, myself, and Syngenta Trizene Network and other stakeholders. So on the specific studies themselves, the Lampert and Dettenbeck studies, we agree that studies are invalid and should be removed. And there are, as Gary noted, we have submitted comments on the white paper to the docket, and so you can find more details on our thoughts there. We also agree that the University of Kansas studies and the Sagan studies, although there are deficiencies, we agree that those studies should be retained, and we agree with EPA's effect scores. Ultimately, though, if we were to do a weighted analysis that took account of scores on data quality and reliability and so on, those studies would probably be down weighted somewhat compared to, say, the study that Richard presented from the Baylor mesocosm study. Finally, on Kaczynski, we agree that studies should be retained, but perhaps of all the studies, that probably has the weakest support and would carry the lowest weight in a weighted analysis. We also do not agree that the acute 100 microgram per liter treatment involved a 21-day exposure, as levels almost certainly declined during the observation period quite significantly. And as Jeff pointed out, we have concerns about whether that 10 microgram, that chronic 10 microgram liter treatment really did cause effects. And so we are hopeful that the panel will take a detailed look at that particular study and that particular treatment. Next slide, please. So what I'm going to switch from, rather than repeat all of what you've heard so far today, is where do we go from here? First, with regard to the COSM database, as I said, I think EPA has done a fantastic job evaluating the 11 controversial studies that are the focus of this SAP. What we would like to see is the agency apply that same level of rigor to a couple of other controversial studies. I won't go into them because Jeff's already covered them, but the Pinard et al., Baxter et al., and the King et al. Study that was described by Richard should all undergo that type of reevaluation. And what we'd even like to see more is actual scoring those studies and assigning weights to those studies so that the really well-done studies like the Baylor et al. Study shown here in the right panel gets a much higher weight than, say, a study that just relied on phytoplankton communities in a beaker. So I'm not going to belabor all that. It's already been covered. What I would like to talk about is the methodology. So we've already heard that the patty model may no longer be functional. I'm not sure about that. It may be that even simpler methods can be used, such as just straightforward logistic regression analysis of the binary scores against 60-day average concentration. And also, I think there's a need to consider other lines of evidence, and I'll get into that for the remainder of my talk. Next slide, please. So this is a slide showing the relationship between exposure duration in log space on the x-axis and nominal concentration on the y-axis. The red dots represent effects as the database now currently stands, and no effect are shown in green. Those red dots that you see at about 50 exposure days at 0.1 and 1 microgram per liter are the Pinard et al. Studies, and we strongly disagree with those scores. And we also strongly disagree with some of the scores are right around 10 micrograms per liter that are scored as effect. And if you change those to green, you'll see that there really is a threshold somewhere around 20 micrograms per liter, above which there are a lot of effects scores and below which there are mostly no effect scores. Next slide shows the same thing. This is just now the y-axis has been converted to 60-day average concentration. But again, those red points that you see down below 10 micrograms per liter, we believe need to be rescored to no effect. Next slide. So this weight of evidence approach that I want to talk about is from a paper that we published in 2017 in the CTAC journal, IEM. And we undertook it because obviously the derivation of an atrazine LC has proven to be a difficult and contentious exercise, multiple SAPs, many years of trying to get the database right and the methodology right. And so we undertook this exercise, and what we did is we evaluated previous approaches that the agency has used and others. We also independently evaluated all the controversial COSM studies in addition to some others, particularly those that are in that range from 30 micrograms per liter and below. And we followed, as Richard recommended, an a priori scheme for evaluating each of those COSM studies. I'm not going to present that here, but it is available with the publication. And then with that, we had a COSM database, and then we conducted a formal weight of evidence assessment, which I'll describe. Next slide. So we already know there's considerable COSM data for aquatic plant communities, but there are also a large number of single species studies. At least 21 genera of algae and aquatic microphytes have been tested, most of those following rigorous protocols. For those genera, EC50s for specific growth rate were determined by Erickson in 2012 as part of the suite of information that was reviewed by the SAP back then. And the reason why specific growth rate is important is it's duration independent. And so we don't have to worry about the fact that some of these tests were conducted for different durations. We considered 4 methods for deriving a level of concern. One is the one that you've already heard, the patty method. Another was the comprehensive aquatic system model, or CASM, that was used actually prior to the patty method, as was the Brock et al. Scoring of COSM results. And then finally, we took another completely different approach. We looked at the EPA's Office of Water method, for deriving water quality criteria, which relies solely on single species tests. Next slide. I'm not going to go through this slide in detail, obviously, but what I wanted to give you a sense of is the rubric that a priori we developed for assessing the Patty method, the CHASM method, the Brock et al. Method, and the water quality criteria method. And we looked at several attributes related to the strength of association between assessment and measurement endpoints. What I mean by that is the assessment endpoint obviously is the protection of at the community level of organization for primary producers in aquatic systems. And the closer the measurement endpoints for the methodology are to that ultimate goal, the higher the score for that methodology. And then linking exposure to response, the ability to see, for example, concentration response curves, incorporate atrazine chemographs in the methodology and so on, all of that led to higher scores. And we go to the next slide. I don't want to go through this in detail, but we also had a key one here was quality and quantity of data. Yeah, as you heard this morning, some of the studies were not, some of the COSM studies were not particularly well done or had poor reporting of methods and results, and those would receive a low score. Well, same with the various methodologies. And so if the model was well characterized, the inputs were well characterized and repeatable and followed standard practices and so on, then it got a higher score. And then finally, we had 3 attributes related to design and execution. Habitat specificity refers to whether we can use the model to investigate more specific conditions, and those received high scores versus those that were unable to consider local conditions. And that is important when you ultimately develop mitigation measures, because mitigation measures are never a one-size-fits-all across all of the United States. They need to be specific to where those farms and growers are located. Sensitivity refers to the inputs. If one or subtle changes to 1 or 2 inputs completely changes the conclusion, that's problematic, and that would receive a low score. Whereas if the methodology is insensitive to small changes of 1 or a few inputs, then it's more robust, and so we get a higher score. And then quantitativeness is exactly what it sounds like. If the results are qualitative, as you heard, they are in some of the COSM studies, and they also are with some of the methodologies, that would get a low score. If it's highly quantitative and directly translates to apical endpoints at the community level of organization, then it would get a higher score. So next slide. So now I'll proceed through each of the 4 methods. Patty, you've heard about. It's just stage 1 is really just establishing the COSM database. That's what we're here for. Step 2 is to develop an effects index based on single species toxicity data, and I'll go through each of these in a bit more detail. And then we apply that effects index to each study, COSM study endpoint, define the effects as an index-based level of concern, incorporate the chemographs from the COSM studies themselves, and from that you can get convert back to a concentration equivalent level of concern for whatever duration you're interested in. The EPA has chosen to focus on a 60-day duration because that's roughly the window during which atrazine is applied in the real world. Next slide. So this is that state, we call step 2 here, but it's actually stage 2 from the previous slide. So these are the results at the genus level for single species toxicity studies. On the x-axis, we have log concentration. The y-axis percent rank, and if you look at the numbers closely, you'll realize that's probits. And we see species like Najas, or Najas, however you say it, is the most sensitive species, and that's for specific growth rate, EC50, all the way up to Cryptomona at the top right, which has an EC50 of over 500 micrograms per liter. And in each of these studies, a concentration response curve was derived. So we have a probit slope, we have the EC50, and then we can, from that, generate a concentration response curve for each species. And so we can go to any concentration on the x-axis, say 50 micrograms per liter, and figure out how much of an effect there was to each of these species on this distribution. Next slide. And that's what you get here. And you can calculate an average effect across all species. And at 50 micrograms per liter, that turns out to be a 19% effect. And so this is the index that the PADI model creates and relies on pre-calibration step. So next slide. So then the next thing to do is to characterize each of the COSM results in terms of the chemograph that can be derived for them and converted to a 60-day average concentration. And we essentially regress the PADI model output, which is the effects index I just talked about, against probability of effect. And the open triangles are the no effect scores, the closed triangles are the effect scores, and the LOC is essentially the 50th centile of that logistic regression. Sounds complicated, but really it all comes down to that final calibration exercise that drives the eventual LOC. Next slide. So very quickly, we talk about all the advantages and disadvantages in much greater detail in the paper, so I'll just give you a flavor of it here. So advantages, it's directly relevant to the protection goal, which is protection of aquatic plant communities. And that's exactly what the model is trying to do. It can be used to evaluate time-varying concentrations in the environment and also time-varying concentrations in the COSM studies. It puts everything into a common currency. Obviously endorsed by EPA, perhaps a more tepid response from the SAP for reasons I won't go into. And specific growth rate metric also can be used to combine test results across studies of different duration, as I mentioned. So all of these are advantages. Disadvantages is the methodology does not really consider magnitude of effect. It's a binary score system. There's a no effect or there's an effect, but of course, in reality, there's all variations in between. And it also doesn't really consider the potential for recovery. Does not consider timing of applications, not really specific to any habitats in particular. And as we've all heard multiple times now, it is very sensitive to scoring of COSM results. Next slide. So we scored the PADI method against all the attributes in that rubric I showed you earlier. But in this case, we actually did it using the PADI method as it was used by Giddings in 2012 with a COSM database that was supported by the SAP. And so you see, for example, a high weighting for the biological linkage between measurement and assessment endpoints, as I mentioned. Data quality and quantity are an issue because of the reliance on COSM studies, some of them of dubious quality. And overall, using the Giddings database, we gave this a score of 9 out of 15. Next slide. This is the CHASM model. It is a mechanistic model. Next slide. That includes, so it's a bioenergetics food web model. It's designed to mimic second and third order Midwestern streams where atrazine is heavily used. Includes 20 phytoplankton or periphyton species, 6 macrophyte species, and bacteria, zooplankton, invertebrates, and fish consumers. So it's an entire functioning aquatic system. It uses single species results from that distribution I showed earlier to parameterize the effects to each taxon. And then it uses COSM data both to calibrate and evaluate model performance. There's a lot of information on this model. I have no time to go into it in any more detail than that, but it is a well-accepted model. It's been used for a variety of purposes besides deriving an LOC for atrazine. It's directly relevant to the protection goal. When modeled effects were compared to measured effects in COSMs using a split database, it did very well. And it also evaluates effects and recovery, 2 things that the PADI model does not do, and includes indirect effects. Disadvantages, it has a lot of inputs, and it takes a lot of time to put those inputs together. It requires some expertise to be able to run the model. And it is very site specific. And the SAP, in fact, thought that it was maybe too site specific. Next slide. So we evaluated this line of evidence like we did the others. Ultimately led to a proposed LOC of 18 micrograms per liter. That 60-day LOC is very robust to changes in input parameters. So it scored very high on sensitivity, for example, scored high in the biological linkage between measurement and assessment endpoints, and so on. And overall ended up the highest score of the 4 methods we evaluated, 11 out of 15. Next slide. Brock et al. Was actually the methodology used even prior to the PADI method and CHASM method. And instead of having a binary scoring system, as we heard from EPA this morning, it actually has several intervening possibilities. So a 1 score is no effect, 2 scores slight effect. Those 2 categories ultimately become a no effect in the binary scoring system. A 3 score is a significant effect, but a recovery to control levels within 56 days. 4 is a significant effect without return to control levels during an observation period of less than 56 days. And as you heard, there are a number of COSM studies that didn't even include recovery periods, so some of those could be scored 4. And 5 is a significant effect without return to control levels for more than 56 days. Essentially, you can regress scores versus test concentration. You need to count for exposure duration in that analysis. And I've already mentioned those points. Next slide. Of all the methodologies, this one got the weakest score because it is entirely reliant on the COSM studies. We did reevaluate and the controversial studies, and we evaluated some of the newer studies that Jeff talked about. Many were unacceptable, particularly those close to the LOC values, and that creates uncertainty. It did score well on the biological linkage between measurement and assessment endpoints, but generally did not score all that well for other categories, and so got an overall score of 6 out of 15. Next slide. And finally, the water quality criteria method. This should probably be familiar to a lot of you. We basically took that species or genus distribution that I showed earlier and fit a number of possible species sensitivity distributions to that data set. And ultimately, the log logistic model was the best fitting model. And then divided the resulting concentration that affects 5% of the taxa by 2, as recommended in the water quality criteria method. And that led to an LOC of 26 micrograms per liter. This methodology scores well, for example, on data quality and quantity because it relies entirely on study results from protocols that have been developed and used for a long period of time. They're very reproducible. But it scored poorly on, say, the biological linkage between measurement and assessment endpoints, because we're really not considering things like community level responses, indirect effects, and so on. And overall, I ended up with an intermediate score of 9.67. Next slide. So bringing it all together, you see that we have the 4 methods. The LOCs, when we rely on what we think is a high quality COSM data set, the LOCs are remarkably similar across the 4 quite different methods, ranging from 18 to 26 micrograms per liter. And all we simply did then is we took the weight of evidence score and basically weighted each of those LOCs and came up with an overall value of 23 micrograms per liter is what we believe to be a reasonable LOC for atrazine. That LOC, we believe, is supported by the results from that Baylor study by King et al. In 2014 that Richard described. And also Giddings using also a COSM database that we believe is of high quality, derived an LOC of 21.2 micrograms per liter with the PADI model. And so, when you have a high quality COSM data set, they all seem to land in that area of somewhere around 18 to 25 micrograms per liter. And so ultimately, we believe that's the correct place to be for the atrazine LOC. The weight of evidence approach I just described is very similar to approach that is advocated by EPA scientists in the Office for Research and Development. Glenn Suter, who worked there at the time, stated in a subsequent paper that during preparation of his paper describing the weight of evidence approach, an example of weight of evidence for quantities appeared that derives an LOC for atrazine risk to aquatic plants in a way that is remarkably consistent with this framework. And so we believe that the framework is something that EPA should consider in the future as they sit down to revise the atrazine LOC. Next slide. So in conclusion, the white paper represents an important first step in the process for deriving what we believe is scientifically defensible LOC for atrazine. As I said before, I thought it was an excellent, well-written, in-depth review, and the presentations that we heard this morning and early afternoon further showed that a lot of thought went into it by the EPA, and we commend their efforts. We also concur with the recommendations in the white paper, as Jeff previously noticed. Going forward, we believe the revised LOC should continue to be protective of aquatic plant communities. That's obviously the goal here. And as Gary stated, we want to follow the science to get there. It should take advantage of the extensive COSM and single species data sets using a weight of evidence approach, but we would like to see it be more weighted in the future so that studies of highest quality are receiving higher weights than those of lower quality. Should consider a range of methods and possibly simpler methods than the padding model, as I mentioned. And the final point here is important. As Richard said, atrazine is one of the most studied chemicals on the planet. We have a fantastic amount of COSM data and single species data. And there's no need for hyperconservatism given that strength of the data set. And we also want to avoid hyperconservatism because of the ultimate cost to growers and consumers. And you'll hear from, you've already heard from Gary, you'll hear from a number of grower associations tomorrow morning, I believe, that will show you how important it is to get the LOC just right so that mitigations are only required where they are absolutely necessary to protect the environment. Trizene Network looks forward to working with the EPA and other stakeholders on development of a revised LOC for atrazine, and I thank you for your time. I'd be happy to answer any questions if there are any.
Okay, Mr. Krissick. Dr. Krissick.
Okay.
Good afternoon. If you're ready, I'll proceed, Mr. Chairman.
Please do. Go for it.
Thanks, sir. I am Greg Krissick. I'm co-chair of the Trizene Network. Recently have served as CEO of the Kansas Corn Growers for 9 years. Previously in my career, I was also the pesticide director for the state of Kansas, where I began working on the atrazine issue about 30 years ago as of this summer. First of all, I'd like to thank both the SAP and the agency for the opportunity and accommodating all of our requests this afternoon for the amount of comment time during the public comment period. We do greatly appreciate that. I have worked with corn farmers, but as you have heard, the network actually includes farmers of citrus, sorghum, sugarcane, and many other crops. And so I guess I'm here to simply confirm for you that the availability of this product is very, very important to farmers, as is the process and the matter that the SAP is reviewing and deliberating about. It's a very important item for farmers. I believe this network, this coalition of grower groups is very, very unique and one of a kind when it comes to any pesticide or herbicide product. And you've heard many examples here of the length and duration, not only of the use of the product, the study of the product, and the importance of the product. Farmers that we work with are expert in agronomics and agricultural technology, but they are not experts, as you are, in things like mesocosm and microcosm studies. So we have served as kind of a conduit between farmers and the experts in explaining the items under consideration. And as Dr. Moore has just reviewed, we share this information with our growers who are increasingly more and more technologically savvy and have been working on regulatory and conservation issues for years. And that is easily progressing into climate smart type approaches as well. Obviously, with all the presentations, you are very familiar now with the white paper and the findings. Thank you to the agency for the excellent summaries given today. But adopting the findings of the white paper will not only contribute to strengthening the database by excluding poor quality studies or mischaracterized endpoints that would otherwise create an inaccurate CLOC for atrazine in the future. As you know, this does not exist in a vacuum. This step is really the first of many steps in a chain that will lead to the ultimate program that will affect the farmers out there in the real world as they do farming and food production. And so the studies, the 11 studies in this white paper and this SAP, getting that correct is very important, but there may be other future items in that chain, such as the modeling that's been discussed that might even be needed for SAP review in order to create the best program that we possibly can have. Because ultimately, acres and practices are affected by these calculations in current food and agriculture ecosystems, where farmers are working either in what may be in and around water and water quality issues or other types of erosion. For example, in Kansas, and you may hear from one tomorrow, where the potential impacts of the maps and the mitigation are in areas where there simply is no water runoff. It just doesn't happen. So what we want to prevent is working with farmers who may look at other options if they do not have access to this product. And that is most often increased tillage, which would fly in the face of climate sustaining technology that has been implemented in these cropping systems. So very important, your work. And we work with farmers who often feel that they are being judged or being judged by the public in ways that indicate that they would be using more and more inputs when that simply is not the case. They want sound science for their programs so that they can control their invasive weeds and raise healthy crops on their family farms. They continue, as I've mentioned, to invest in significant technology from carbon smart farming, sustainable farming, no-till conservation tillage, precision agriculture with satellite imagery, spray nozzle technology, and more. And these always result in reduced input amounts used on whatever crop they are growing. So if you were to stop at a farm, which we invite you to do, you'd find a farmer climbing into their tractor cab that's loaded with computer screens of satellite imagery, yield data, soil maps, so that variable rate sprayers ensure that each part of the field gets exactly the amount of crop input it needs. So if we can move to remove any questionable science in future EPA decisions, we can prevent farmers losing the ability to use this product or other products and not using other alternatives, which we think would have cause significant steps backward related to carbon smart technology. I hope you'll agree that the EPA's white paper recommendations and our scientific analysis that the network has shared with you will help you find the decision in answering your charged questions and adopting these studies and adopting the new science and the best science possible in that regard. So with that, thank you for your time and happy to stand for any questions.
Great. Thank you very much. Thank you very much. Okay, panel. That brings us to the end of the first day.
Dr. Chapin, can I interrupt? I just want to back up into asking any clarifying questions from our previous oral public commenters to the panel. So just want to get that in there, get an opportunity for anyone.
So the question is, does the panel have any clarifying questions for the presenters? Right?
Yes.
Okay. Anybody? All right, I'm not seeing any hands.
Dr. Barakal.
Yeah, mine
Okay.
is a request.
I'm
that-
sorry, Dr. Barakal.
Yes, sorry. Yes, mine is more a request than a question. I was wondering if, since the presentations were very good in explaining the studies, and if we could have the copy of the slides.
Yes. You all will receive a copy today.
Okay, great. Thank you.
Any other questions? I don't see any. You happy, Tamu? Are we good? Sorry, you're on mute, girl.
Yes, always,
Okay.
always happy.
Okay.
Yeah.
All right, excellent. Okay, so I think that brings us to the end of the first day. So tomorrow we will start off at 7 a.m. Pacific time. That is 10 o'clock Eastern. And we'll spend the morning listening to a bunch more public comments. And then we'll have lunch and we will dive into the charge questions. I will remind our panelists that now is a good time to be, probably now is late to start, but it's a good time to continue discussions among yourselves within each charge question to make, just to sort of see how far you can get to a point of consensus on answering your charge questions. And so
one note,
feel
Dr.
free.
Chapin, one clarification, Dr. Chapin, I apologize for interrupting.
It's okay.
We still have a number of oral public commenters on tomorrow. Thereafter, we will deliberate. So there are a number, a set of presentations also for tomorrow.
Sorry, I thought
In the morning,
I thought
yeah.
I covered. Yes, I covered that. That's so. All right. So in the morning, we'll reconvene 7 a.m. Pacific time, 10 a.m. Eastern. Thank you all for being here today. Thank you for your attention. Thank you for the EPA presenters, and we'll see you guys tomorrow.
And this meeting has been, and thank you so much all for your participation, for the public and their participation, and as well as the panel and the public commenters. And this meeting has been adjourned for today. Day 2 tomorrow.